Okay, I think we will get started. If you could take your seats, please. Good morning and greetings, everyone. It's a great privilege to welcome you to today's event, Innovation at the Food, Energy, Water Nexus, and also to welcome you here to Marquette Law School. My name is Dave Striffling, and I am the director of the Water Law and Policy Initiative here at the Law School. And I'll serve as something of a Master of Ceremonies for the event today. And my first task in that respect is to welcome the person who will deliver our introductory remarks this morning, Dr. Jean Hassenlap. Among many other duties, Jean serves as Marquette University's Vice President for Research and Innovation and directs Marquette's presence in the Global Water Center. We're very grateful that she's here today to give us some words of welcome. Jean.
Thank you, Dave, and good morning, everyone. Welcome to today's interdisciplinary workshop on innovation at the Food, Water, Energy Nexus. I'd first like to start off by thanking Dave Striffling, the director of our law school's Water Law and Policy Initiative, for putting together this thought-provoking set of discussions today. The Water, Food, Energy Nexus connects some of the biggest challenges facing our world today, and it's a place where innovation is so badly needed to create just and sustainable solutions to these challenges. I'd also like to thank the Water Equipment and Policy Center, that is a joint endeavor of Marquette University and the University of Wisconsin-Milwaukee, funded by the National Science Foundation and supported by a growing number of companies, some of whom are represented here today. The Water Equipment Policy Center supports faculty and student research on problems and issues that are important to our corporate partners, and really is the starting point for moving water technology and policy work forward in this area. And we appreciate their support, not just for this event today, but for all the work that comes out of the center. Milwaukee, as many of you know, has positioned itself to be a global water hub through collaborative vision of bringing together academic institutions, established corporations and startups, government, nonprofits, all coming together to provide innovative solutions to the world's water problems. Some of you here today have played a critical role in the formation of this shared initiative that is led by the Water Council here in Milwaukee. The Global Water Center, which is located just a little over a mile from here, provides a site that brings together public and private sectors. Marquette was pleased to move into the Global Water Center. We took the last available space just a little over a year ago, more like a year and a half. And our space is used to bring together water quality and water management engineers, biologists and chemists, faculty from education, and of course the law school, outreach programs such as our university's Upward Bound program that serves students, high school students from economically disadvantaged backgrounds, and even the Haggerty Museum of Art has a presence in our space in the Global Water Center, all looking from their different frameworks in collaboration at water issues and water opportunities. This year, the team of faculty who work down there have also launched a water conversation series so that we can bring some of the Marquette folks together with the residents of the building to talk about our varied perspectives on water. The site itself provides great opportunities for all of our students and faculty to collaborate. The University of Wisconsin-Milwaukee is just above us in that site, and our faculty can go back and forth between the two facilities. We've tried to build our resources collaboratively so that they provide complementary equipment to what's upstairs in UWM space. This provides a lot of opportunities, and there's so many different people in this building. It's really an exciting place to go just sit, have a cup of coffee, and see who's talking to who about water issues. We've also got a lot going on here on campus. We've got an outstanding water quality center housed in the Opus College of Engineering that serves the community and is a base for a lot of the water quality research here on campus. We've got academic programs in environmental engineering and an interdisciplinary program now in environmental studies, which draws students from around campus with a broad array of interests. And of course, the Water Law and Policy Initiative right here in the law school. Just last week, I took the university's Committee on Research, which is a faculty group that supports the internal funding of research on campus. And we did a walking tour of some of the laboratories on campus. And one of the ones we visited works very intimately at the water-food nexus. It's Michael Schlappe's lab in the Department of Biological Sciences. And Michael is a plant geneticist who studies rice. And his goal here at Marquette had been to look at cold-tolerant rice that could be adapted for farming in Wisconsin. Now, rice is a very water-intensive commodity to try and grow, and so part of his research, he has a small test rice paddy on the roof of the biology building where they look at different cultivation methods to see if they could be a little less water-intensive, although he finds that flooding the paddy still works the best. But he's also cooperating with folks such as Alice's Garden, which is just a bit north of here, which is a community garden, the Fondy Food Markets, test gardens, to go out into the community. And what they're looking to do ultimately is to build a sustainable rice cultivation business model for this region. And so lot of things going on here, and they're not always labeled water. But this nexus, this idea that energy, water, and food are so intimately connected is really important as part of our larger research programs here at Marquette. So we're delighted that all of you are here today to explore some of these issues, and I wish you the best for a day of creative and innovative conversations. Thank you.
Thank you, Jean. As Jean indicated, I stand here this morning as the representative of a larger organizing committee that created the real vision for this event, and we certainly hope that our agenda today will provoke much discussion and interesting conversation among us. And toward that end, we have brought a number of national and local experts, policymakers, and thought leaders here to Milwaukee and to the law school, and we're very grateful, as Jean mentioned, for the support of the conference sponsor, the National Science Foundation Industry University Cooperative Research Center for Water Equipment and Policy. This wouldn't be possible without that support. Our speakers and panelists will present a variety of perspectives and will help to educate us all about these critical issues. And in the interest of making this a true conversation, we have 2 breakout sessions planned at which we'll all get to talk about and exchange ideas about these issues. At the end of every session, also, there will be time set aside for questions from all of you in the audience. And in the interest of making the session more valuable for everyone, we have several student assistants who are here taking down notes about what the discussion, where the discussion goes, and after the conference, we'll circulate those to everybody in the form of a summary of discussion or perhaps a short white paper to everyone who has attended. Student development is a very important part of the NSF IUCRC program, so I encourage you to get to know these students throughout the course of the day. I know we also have a number of students in attendance, and one of our law students will even moderate the afternoon panel. But I'm getting ahead of myself. Before I introduce our first speaker, I want to make a procedural point or two and to ask for your help in keeping us on time today. Our events here at the law school have a hard-earned reputation of keeping on schedule, as those of you who have attended some of them know, and all of our participants and attendees contribute to that. So we have several scheduled breaks today. The first is at 10:20 this morning. There's another for lunch, of course, during which we'll conduct our first breakout session, and then we'll have a final break later this afternoon. So I'll ask you to be back on time from those breaks so we can start again promptly. And finally, last but not least, if during the day you need the restroom, you'll find it behind the bank of elevators that you came in by. With that, let me introduce our first speaker, Kevin Schaefer, who will discuss energy use, recovery, and minimization at water and wastewater utilities. Kevin is the executive director of the Milwaukee Metropolitan Sewerage District. He's responsible for the overall management, administration, leadership, and direction for MMSD in meeting its short and long-term objectives. He's uniquely positioned, I think, to kick off our discussion today by describing MMSD's really commendable efforts, I think, in bringing together the various threads of the Nexus we'll discuss today. So please join me in welcoming Kevin Schaefer.
Dave asked me if I wanted the lights dimmed when I was speaking, and I thought y'all would probably like that. So, good morning. Thank you for having me here today. If you were just sitting there and you didn't see the words on the slide or the logo, you'd think you were looking out a window. It just is a great picture of Milwaukee, and I wish I could say everything was always so calm and settling here, but we always have issues like any urban setting in the region. But our goal is to always try to make life as good for people as we can, to protect them from some of the hazards of water damage that they might exist or experience. And we do that every day. So we go to work every day trying to protect this natural resource, protect the economy, and protect the lives of the folks that live here. Last night we had a pretty good storm. We had anywhere from 3/4 to an inch of rain. No overflows, Russ, from DNR, no overflows. We're all good. But it was a lot of rain, and today we'll probably treat over 200 million gallons of water. I say that number a lot, but 200 million gallons of water in one day, that's a lot of water. It'll be cleaned, put back into the lake, and then we'll draw it out later to use it again for drinking water. And, I can tell you that's probably what we'll do today. Tomorrow, I don't know what we're going to do. The day after that, I don't know what's going to happen, because we can't tell the future. But we know that it's going to change. We know there's going to be new regulations or less regulations. There's going to be some change in regulations. We know that the climate's changing, and we've experienced it here in Milwaukee, and we're going to experience it again moving forward. So we need to adapt. We need to be able to look at those changes and move forward. And I really look to research the IUCRC, and Dave did a great job of naming it out, but I just say IUCRC has been a phenomenal partner for us, a great effort. The Water Council, another great partner to really bring that science, that research, that know-how, both to the public sector and the private sector on how we do things. So I'm going to go through some upfront slides to talk about water, because I focus on water, but the two things we really have to look at is air and water. How do we preserve those? How do we keep them clean for our future environments? So the USGS says that if you took all the water in the air, the seas, the rivers, the lakes, everything, we'd have about a circle, that big blue circle, of about 860 miles diameter. Seems weird, doesn't it? And you can just barely see a smaller blue circle if you took all the liquid fresh water. That's 170-mile diameter. And then if you took all the freshwater lakes and rivers, it's 35-mile diameter. Every time I see this picture, I think it's got to be wrong. It just looks wrong. But it's on the internet, so it's got to be right? Because everything on the internet's correct. So this tells you what a limited resource we have, if it's true. And it's USGS, so I think it's true. The limited resource we have to protect, and we have to do all we can to utilize it the most in all the ways that we can wisely. Just some statistics. We use about 176 gallons of water per day. Probably don't think you use that much, but we do. 40% of our water is used to produce food, so here's that food, water, energy nexus starting. And you can see the different uses of water in the home. And if we were to build the equivalent of soda pop, soda, Coke, whatever, our prices would go up around 10,000%. So it's underpriced. It's a small resource. We need to do more to protect it. So just some more statistics. 350 billion gallons of fresh water withdrawn every day. 41% of the water is used for either electricity or irrigation, 37%. 4% for transportation. And 1/3 of the country's counties in our lower 48 states face high risks of water shortages. So the United States, one of the wealthiest, most well-to-do countries in the world, is facing water shortages in 1/3 of our counties. 1/5, and equating it to the economy, 1/5 of the U.S. economy would grind to a halt without reliable clean water. 46% of water consumed is for manufacturing. 1 in 3.5, 3.7 water jobs multipliers. Every job we do in water, there's 3.7 created. And for every dollar spent, there's a $6 return. So it seems like an investment in water makes a lot of sense. It's a limited resource. We need it to grow food, to produce energy, to live, and yet we're not really investing in water the way we should. These are all the valueofwater.org. You see the website. These are all statistics off of that website, which I'm also a member of. And here's our challenges. I'm not going to read through all these, except we're getting a D in our infrastructure. A D. How many students here want a D? How many parents want their kids coming home with a D? We don't. So we got to do more. We got to do better, and the cost is tremendous over the next 20 years. So how do we find the money? How do we bring this resource back to where it should be in the prominence of investing and make it something that we really value? So we have an opportunity. We got close to 69,000 water and wastewater utilities in the U.S. And when we treat wastewater, there's the potential to create energy 10 times greater than the energy used to clean it. So here we've got not only a water reclamation facility, but an energy reclamation facility. Wastewater plants can be the energy plants of the future. And we do that by moving towards more efficient infrastructure, which I'll talk about a little bit what we're doing at MMSD. And we also have to move towards renewable energy, which we're doing pretty gung-ho right now at MMSD. So that was kind of the intro of why we think water is important. I think everyone hopes and knows that water is important, but it is. So let's focus a little bit more on MMSD, Milwaukee Metropolitan Sewage District. 411 square mile area, 1.1 million people, 28 different municipalities. If you're from this area, we go from St. Mary's Hospital to the north, down to the Racine County line on the south. To the east is the lake, and to the west, most of the time, is the subcontinental divide, which is the divide between water that goes to the lake and Mississippi River. Except for right in here, back in the 60s, we approved extending our sewer service area beyond the subcontinental divide. So we actually take water from the other side and bring it back to the lake. We convey and store and treat wastewater. We do flood management. We also own about 300 miles of pipe in our region, and there's another 6,000 miles either private or publicly owned. So we have this great infrastructure, but we only control a small piece of it. So how do we partner as a region to get other folks to understand the importance of what we do? We also have a mixed sewer system. One is a combined sewer, which is this dashed area here, and a separate sewer area. Combined sewer is an area that takes water, a pipe that takes water from both rainwater and sanitary flow. It's combined. That's why we call it that. And a separate sewer system where it's either a pipe for stormwater or a ditch for stormwater, and then another pipe for sanitary flow. That delivers flow down to 2 water reclamation facilities. They used to be POTWs. Now we call them water reclamation facilities because we're reclaiming water. You'll see a lot of utilities calling them resource recovery, and you'll hear some of that today with some of the other presenters. And a 521 million gallon tunnel. Here's our 2 water reclamation facilities. You can go online, mmsd.com, look at the weather center, and this will tell you within 5 minutes how much water we're treating at each facility. Before we started this morning, after the storm last night, we were at about 150 at Jones Island, 150 MGD, and at South Shore we were around 135 MGD. On a normal day, they'll treat about 75 million gallons a day each. So that's where I know we're going to treat this 200 million gallons today. Normal treatment process, Jones Island's right downtown, South Shore's on the south side. Jones Island's been operating since 1926. South Shore's been operating since 1968. And we take flow from the entire region and take it to those 2 points. I live up here in Fox Point. When I flush the toilet, when I take a shower, when I do laundry, any water I use in the house, it goes all the way around to South Shore. You would think it would go to Jones Island, but it doesn't. Just the way the system was developed. Our deep tunnel system, it's a big bathtub. It's 300 feet below ground. It just holds water. So during those peak storms, we take the water, it spills into the tunnel, into the bathtub, we hold it there. 521 million gallons of storage. Last night, I saw it get up to around 40, and then I went to bed because I could tell the storm was going away. So I don't know what it actually peaked at, but somewhere in the 40 million gallons. So had an inch of rain, 40 million gallons into the system. We still had a lot of capacity left. Believe me, there's a lot of storms where we're not so lucky. We have huge storms hit here. 28.5 miles long, 17 to 32 feet in diameter, designed to have overflows. It was not designed for zero. The lawyers, the engineers, the politicians, the regulators, everyone said, you need to have a system that's going to do the most it can, but you can't afford to do all of it. So it was designed to have 1.6 CSOs, combined sewer overflows per year, way back when it was designed. It's been operational since 1993. Today we're at about 2.2, 2.3, so we're pretty close. We used to have 50 to 60 overflows per year. So we're pretty close to the design criteria that the engineers were given. I'm an engineer. But if you look at every drop of water that comes to the system, we capture and clean 98.4% of it. So when you read about overflows in Milwaukee, which is not very often anymore, thank God, 1.6% of the water is all that gets out of our system. Now, how many people would like to go home with a 98.4 on their grade card? I would. I never had one that good. So we're capturing and cleaning almost everything, and it started in August 1993. And that's a real picture. So there is a pot of gold at the end of the rainbow. It's Milorganite. That's the Jones Island plant where we make the Milorganite product. So in 2009, I wrote a vision, and my commission then adopted it in 2010. I wasn't sure they would. It's a little radical. But I said, if I'm going to do this the rest of my career, I'm going to make a change and not just do the same old thing every day, because we would never get ahead of the curve, right? We'd never be able to improve ourselves. So if you think about this on two sides, the left side is the integrated watershed management approach. We're going to have zero overflows. That's combined sewer engineers in the room, start laughing. Combined sewer overflows, zero. Separate sewer overflows, zero. Homes in the 100-year floodplain, zero. Right now, as I said, we're averaging about 2.2, 2.3 CSOs. Our last combined sewer overflow was last September, a large storm. We're taking steps, which I'll talk about, on trying to get that number down even more. So they don't happen a lot. But zero CSOs in the engineering world is something people laugh at when they're engineers. We're going to acquire land to reduce flooding. We call it the Green Seams program. We're going to build flood management as well. We're going to capture the first half inch of rainfall with green infrastructure. So if we can capture that first half inch, that water does not make it to the tunnel. Where does that take us on our overflow numbers? We're going to try to harvest that rain or that water as well, even in a water-rich area. On the right side, which is really what we're talking about mostly today, although it all mixes together, it's all the same. We're going to meet 100% of our energy needs with renewable energy. So we're converting off of the fossil fuels. It's happening today, right now, it's going. And we're going to have 80% of that energy self-produced. So we're going to produce our own energy and become that energy plant that I talked about. It's already happening today. We're going to sequester carbon with our Green Seams program, and we're going to reduce our footprint from 2005 baseline by 90%. Phew. Just makes me tired reading it, right? A lot of work, a lot of great staff. A lot of them are here today. We're doing some really cool stuff. And cool is the best word I can think about for you. It's cool stuff. So there it is. Another picture that I think you're just looking out the window on. This is a drone at night. You think you're looking at downtown Milwaukee, you're looking at the Jones Island Water Reclamation Facility. That's a wastewater plant. That's a water reclamation facility. It's a resource recovery facility. I just like the picture. So I mentioned Milorganite, Milwaukee Organic Nitrogen. We've been doing this since 1926. We're recovering nutrients that used to go out. We'd put them in a landfill, we'd send them out to we'd burn them, we'd do anything, and that's still happening today. We've been producing Milorganite for over 90 years, capturing the nutrients that are in our poop, right? Converting that, putting clean water back in the lake, taking the biosolids from that process, dewatering it, drying it, producing a fertilizer that last year we sold over $9 million of fertilizer around the country, or actually North America, in North America. Food, energy, water nexus. We're putting the fertilizer back in the ground to grow the food that we need to eat, that we then pass through our bodies, that we then put back in the waste stream, that we then start the process again on. If you know anything about phosphorus, we're mining phosphorus faster than we have. We're exhausting the resource, and this is a renewable source of phosphorus for us to use for fertilizer in the future. I talked about energy efficiency as well, and in 2009 we started, again, 2009, 2010, we passed the vision. We started looking at energy efficiency at the plants. We replaced some blowers at the plants, saved around $800,000. It's about $2 million a year in efficiency. So when you do all this work, you want to also be able to go to your ratepayers and say, oh, by the way, we're saving you money, right? Because if you tell them you're going to spend more and improve the environment, a lot of times that discussion doesn't go as far as you'd like it to go. Here's some of the numbers. So we improved the blower system. The Jones Island PAC is the processed air compressor unit that uses a lot of energy. When we do secondary treatment with wastewater, you pump air into that secondary treatment. This is where the microbes live. They're the workhorses to cleaning our wastewater. And we pump air into these tanks so that they can survive. These folks have great lives. All they do is they eat, reproduce, and die. When they die, we take them off, we make malorganite out of them, it goes back into the process, right? So we have to do this, and you can see the energy savings that we've gotten since this came online. Here's some more numbers showing some of the energy efficiency. So the first thing we have to do as water, wastewater utilities is drive our usage down, become as efficient as we can. That takes money. Drive that efficiency as high as it can be. Try to use less energy up front. And you can see some of the numbers here. And as you saw from the vision, we also have to go renewable. So on the upper left is some solar panels. Focus on Energy helped us pay for this. It's a state program, helped us pay for this. Almost did not pass my commission, but they ended up doing it. And now it just produces energy every day. No one even thinks about it anymore. On the lower left, we have a landfill gas pipeline project, which I'll talk about. These are turbines that take landfill gas that used to be flared off into the environment, and we're burning that landfill gas instead of natural gas, producing electricity, powering up to 14.7 megawatts of power at the Jones Island plant. That's operational today, right now. And then on the right, we have generators down at South Shore. We capture the heat off both the turbines and the generators. Combined heat power, we capture that heat. At Jones Island, we take that heat and use it to help dry malorganite so that we're not having to burn as much energy to dry the process. So let's delve into the landfill gas pipeline project. 2008, we have an operator of our system, Veolia Water, came to me in 2008 and they said, we got this great idea. Our sister company operates a landfill in Muskego. We want to build a pipeline. We want to capture that landfill gas and we want to take it down to Jones Island and burn it instead of natural gas. When I stopped laughing, I said, okay, let's prove it. They actually did. And my staff spent a year looking at the business case for this. And it all panned out. So right now, today, we are taking landfill gas from the Advanced Disposal, Emerald Park Landfill in Muskego. They're treating that gas. We're pumping it 19 miles through a pipeline we built down to Jones Island. We are currently looking to modify some burners that we're using to dry malorganite with, but we also have built 3 turbines, as I said before, where we're burning that landfill gas right now to reduce our energy use, or our fossil fuel usage. Started full operation in January this year. We're buying landfill gas for 48% of the cost of natural gas, so we're going to our ratepayers and saying we're saving you money. It's less of a carbon footprint for us, so we're hitting our carbon goals that we want. And it's just the right thing to do. And it's cool. Back to that cool word, right? I don't know of any other wastewater or water utility in the country, maybe the world, doing this right now. Here's the turbine building we built, 3 turbines, 14.7 megawatts. We run the plant on around 11 to 12 megawatts a day, just normal weather. When we have to turn on the pumps, so the deep tunnel delivers flow to Jones Island, 330 feet deep, we pump the water up into Jones Island and treat it. When we turn those pumps on, I think it goes up to 22, 23 megawatts-ish. So we still have to buy power when we're doing that, when we're pumping from the tunnel. But these turbines are a big workhorse for us. And again, capturing the waste heat, sending it over the D&D building, drying mill organic with it. Well, these are some early projections. I don't know if it's still this high, but we projected a 95% reduction in our greenhouse gas emissions when this project started. We're probably still on the process of getting to that point. We're not there yet, but it's good for the environment. It's good for the ratepayers. It's good for business. It's good for everyone here. We also have digesters at South Shore. I was talking to someone about this prior to the discussion this morning. So we have these digesters that were put online when South Shore came online in 1968. So think of the technology you have in your cell phone right now. Think of what it probably was like in 1968. That's the technology we were operating under. And we have a huge capacity with these digesters. So what we've done is we've gone in and we've converted 2 of the 8 mixing units. You mix the biosolids. So what we're doing at South Shore is the wastewater comes in, we separate the water from the solids, we take the solids to the digesters, we digest those solids, they produce biogas. The biogas then is burned in generators that we then use that electricity to run the South Shore plant. Again, think of that whole cycle. So we're able to treat waste, which we have to do anyway, and then use that waste to offset our cost and reduce our energy usage. We've replaced 2 of the mixing units with newer technologies, and right now I think I heard there's like a 60% increase in gas production just from those 2 digesters being converted. So we're actually kind of wondering whether we should convert any more because we're not sure we can use all the energy that we can produce. And sometimes dealing with electric utility is not the easiest thing to do. You'd think just sell it back to the electric utility, but that's sometimes not easy. Here's the heat recovery that I talked about. Again, taking that heat burnt from the burning process and utilizing that at both facilities. We're heating buildings, we're heating our digesters, we're keeping things operational without buying renewable or fossil fuels. And then we're still trying to learn this. When we did a study with Marquette and trying to look at, can we take food waste, bring it down to South Shore, we call it high strength waste, and use that organic material to add to the digesters and increase our energy production there. We actually take glycol from the airport, which we've been doing since the 1976 timeframe, I think, where glycol dewaters or de-ices planes. Now they collect it as opposed to letting it run into a river, into the lake. They collect it, they send it to us, and our bugs love it. They just love this glycol. It just makes them want to do more, and they produce more digester gas for us. What we're trying to do now, we built a offloading facility. We're trying to find industries with organic waste that we can haul to South Shore at a cost savings for that company, put it into our digesters, produce more electricity, and pay them for that material. Just to the near east of us is Potawatomi. They've put a digester system in probably 5 years ago, and they're doing the same thing. So they're one of our competitors, but we actually work with them pretty well on this stuff. And then the solar I talked about, we had the solar at Jones Island. We've added solar, that's 40 kilowatt. We added almost 20 kilowatt to our headquarters building. In the lower right is a hot water solar heat system that we added to our lab. And Urbane's the project manager. He loves this project. We have not done this yet, but I think Vancouver has done it, and Glenn, maybe there's others that are doing it. I don't know who all else is doing it, but you see these, there it is. See those little holes? So you hear of geothermal, right? Well, when you pass water through your bodies, it comes out heated. You're your own little furnace for heating that water. That goes into the sewer, and that sewer has heat. So if you could put a sewer thermal system where you tap that heat and use it for heating or cooling, depending on where you're at, again, out in the system, and we have pipes everywhere, you could save energy for folks. This is something we're trying to look at. For us, it's trying to find a pipe that has enough continuous flow to make the economics work on this. So we do report cards. I'm sorry, that's a little blurry. We're at about 20% of our goal. So we said we wanted to be 100% renewable, 80% of it self-produced. We're about 20%. We're going to hit the 100%, I think, around 2025. So we're going to be about 10 years ahead of our goal because the economics work for it, and it's easy to talk about with folks. So that's moving gangbusters. And as we've talked about, and as you've seen, food is fuel. This is something I've done with InSinkErator, and Michael's here. I don't see him right now. Oh, there he is in the front. He'll talk more about this in the future, but we've actually partnered with InSinkErator, telling folks they should put food waste down their food disposal. Now, a lot of utilities don't like this because you have more material, but we want that organic waste to send to the South Shore, to put in the digester, to create electricity, to treat the wastewater, okay? And we did this study with Marquette as well. This was several years ago. So that's all the energy side of things, but if we are trying to be efficient on energy, we also need to be efficient on the water that comes to our system. So can we reduce that volume of water that's coming to us and into people's basements, which then comes to us through the floor drain? Can we make steps to try to manage water better, increase that 98.4%, so my grade card's higher, get people more involved with water management, but also reduce the amount of water that we're treating at the plant so we're not using all the energy we need, or we have been, to treat rainwater. So one of the things we're doing is green seams. We started this, it was probably around 2000, 2001, purchasing land along the rivers so that people don't add impervious cover, concrete, asphalt, roofs, whatever, trying to reduce the flooding downstream. And to date, we've got about 3,300 acres of land that we own. We've got bald eagles. We got a ton of deer. We got a lot of deer. But bald eagles are living on our property. And a lot of these purchases are outside of our sewer service area. So we're not looking within the boundaries of our artificial boundary. We're looking at the watershed. Green infrastructure. So we've got an urban network, the combined sewer system, the separated sewer system. How can we green that area up, become more adaptable to changing climate, reduce the flows that come to our system, improve the quality of life, get people more involved with water management, all of the above, and there's probably a whole bunch more that I didn't mention. And just look at this. We've got almost 32 million gallons of storage. So every time it rains, we've got 32 million gallons of green infrastructure out there capturing water and either delaying its delivery to our system or taking it out of the system and storing it. This is a great water management effort, but it's also a great public involvement effort. So if you want to look at triple bottom line, here's the social side of it. Look at all those happy people planting plants. All I'm doing is providing them the plants for half price, but they're doing all the labor. Good economics for me, too. Green roofs, we got them everywhere. We got 500,000 gallons of green roofs out there storing water. So the roofs on these buildings in the combined sewer area runs right off into the sanitary system that I'm having to treat. Can I keep that water out? Can I delay that peak? We've got some really innovative modeling going on right now to show the impacts of green infrastructure on both combined sewer runoff and separate sewer runoff. There's something called total maximum daily loads, TMDLs. Do you know what those are? TMDLs were put out and approved last August. We're developing an implementation plan now. They've not been approved by EPA yet. They're still in that process. But this will also help the communities meet those water quality loading issues that they're going to have to face. Rain barrels. This is why we do rain barrels. Look at the education going on right there with those folks learning at a young age how to manage water better. Rain barrels hold about 55 gallons of water. That's super. We sell them, so it offsets our cost. Other people install them most of the time, so our cost is next to zero. But the public outreach on this, the public involvement is phenomenal. And just seeing these folks doing this and painting them, that's fun. Just a phenomenal effort. And so this is that whole trying to become more efficient and knowledgeable. The more we can make people knowledgeable of what we're doing, the better they'll understand it when we do have an overflow. Our communities like it so much, they've started, and we didn't do this, they started their own Green Summer program. This is West Dallas. About 5 of my 28 municipalities have started Green Summer programs where they take rain barrels that we provide them, they give them to their neighbor or to their constituents or sell them. And then they have these educational days where they go out and do this work. Brown deer, same thing. And a lot of staff here. This is a great recruiting tool for new employees. Not a lot of people want to go and sit in a wastewater plant the rest of their lives, right? These are things that we can do to make this job more sustainable for them as well. And I just threw this in there because we're talking about food. We're not doing this anymore, but this great guy has a beer cave in his basement, and he was asking us for 50 gallons of our effluent, the water that comes out of our Jones Island plant. He was taking that effluent, distilling it, and making beer. I know Matt and I've had a few, and it's phenomenal. But you're taking wastewater, water that's been treated out of the wastewater plant directly into a bottle that you're drinking beer. I mean, there's some processing. So you're starting to see that cycle occur more and more. And I'm sure others will be talking about this in the other sessions, but we have folks in California pulling groundwater, or putting wastewater into the ground, pulling groundwater out and drinking it. We're going to see more and more of this reuse of water and this tying into food because we're going to have to. Limited supply, back to that first slide, a lot of people to use it. So that's that. I'm a little early. We can take questions if you want me to, Dave.
So,
my question was about, you talked about there being a little bit of resistance for the solar, and I wondered what you think that resistance was, and was there anything that you had to do to overcome it?
So the question was, when we installed these, and it was the first solar cell that we put on Jones Island, there was resistance to doing that. And a lot of it was just the economics at the time when we did it. Energy was relatively low cost. I don't think people understood the benefits of having a renewable supply. It was probably the first renewable energy project that we did in our portfolio of renewables, so it was kind of a learning curve for my commission. They thought, the discussion at that time was trying to go LEED, L-E-E-D, and they're like, well, we're a wastewater plant, you don't want to go LEED. And I go, well, let's just save money then. And so we just talked about the economics of it. And then when Focus on Energy came in and helped us pay for it, that helped a lot by cutting that cost down. And a lot of times we look at payback periods. So is it going to pay for itself in 3 years, 5 years? As I tell folks, if the life of the facility is whatever it is, 15, 20 years, the solar, whatever that number is, we're going to be here forever. It's not like we're a business that might move. we're a wastewater plant. We're here, you know, so let's look at these longer term, longer payback times, and push the industry towards some of that. We're also looking at wind power right now. We've not pulled the string on that one yet. Wouldn't it be cool to see turbines right on the lakefront, similar to what the port has down at their headquarters building? So we're looking at that. Yes, sir. Uh-oh.
Back to the electricity, renewable is great if it pencils out. What is your cost to produce versus the cost to buy in the grid?
For electricity, so for landfill gas, I don't know the exact numbers off the top of my head. I'll give you approximates. Well, actually, I can't even give you approximates. I don't know. How's that? Sure.
Greenhouse gas.
Yep.
Inventory. You guys did a baseline in 2005.
Yes, at Jones Island. Yep.
Do you know of other wastewater treatment plants that are doing greenhouse gas inventories and actually having air emissions as a metric in water quality?
So what I did, where that came from was I had gone out to a NACWA presentation in Portland, Oregon, and they were all over this. I mean, they had already implemented it, and we were just thinking about it at the time. And I came back from that, and I said, this is something we need to at least establish the baseline on, and then we'll know where to go from there. And so I would say the Northwest, Seattle, Portland, that area is doing this now, has been doing it for many years. And that's where we learned that from.
I think it's great. It's just which carbon could be priced.
Oh, yeah. Well, like, I don't know, 2009, 2010, and if you think of the politics of the country at the time, we thought there was going to become a market for this. When we started these discussions with landfill gas, we had companies from New York and everywhere calling us about, well, we need to do this carbon credit program and set all this up and have the framework ready to go. And I wasn't really ready to do that yet. And I guess now I'm kind of glad we didn't, because we've seen where that's gone. But I think it's inevitable. I think it's going to have to happen. Yeah. Wow, all these questions.
Since you mentioned the 60% increase in your biogas with the upgraded mixing system on two of the 8 digesters, I'm curious about the timeline on the other 6, as well as I'm familiar with the challenges you had with siloxanes in your generators and where you might be as far as developing a gas cleaning system.
Yep. So at South Shore, we're taking this gas, we're putting from the digesters, we're burning it in generators. And what we found when we were coming out of the digesters was there was a high siloxane count in that gas, which is very corrosive to the mechanisms themselves, the engine generators. So we decided we were going to put in a gas treatment system. And your timing's good with the question, because last week we opened bids and it came in $2 million over what we thought it was going to be. So we said, "Ooh, hold on." So we're re-looking at the technologies right now. The system runs fine, except we just wear through parts, you know. So we're looking at what we can do now based on that high bid. We'll have to reject that bid and then re-look at that. What was the other half of your question? Oh, the next ones. That's a great question. My operators are like, let's do it now. We're still looking, the linear, we went with 2 different types of technologies for the 2 that we did. I think it's the linear mixing unit is the one that's producing the most gas for us. And it's just a matter of money, trying to find the money to do those next. So it's probably in the next 5 years, we'd maybe do 2 more. Yes, ma'am.
So it sounds like a lot of the developments that MMSD has made is kind of due to the MMSD's sustainable vision. But I was wondering if you could talk about some of the policy or regulatory incentives that helped facilitate buy-in by, you know, by MMSD, by the city, et cetera.
So the question is the policy and regulatory changes that we had to get through to do some of these projects. Most of it, I think, I'll focus on is the green infrastructure side of things. And we actually changed our verbiage ourselves to say that green infrastructure is infrastructure, that it's part of the entire system. That's one of the first changes we made. We started incentivizing the implementation of green infrastructure throughout the system. We pay $5 a square foot for green roasts. We pay so many dollars for different units for the rain barrels, rain gardens, so forth. And we also started collecting taxes from the 28 municipalities and then giving it back to them so that they could implement larger scale green infrastructure. Now, why would we tax and then give it back to them? Why don't they just do it themselves? Because our great state has put revenue limits on our municipalities. They've not put revenue limits on us, and they were unable to even keep up with some of their basic requirements. So it's kind of a shuffle, but it's getting green infrastructure involved and installed where it needs to be. So a lot of it was incentivized with finances. Policy was just starting to talk about it, starting to make my brethren, the engineers, understand that this is, and we're still in that struggle, making engineers understand that this is part of what we need to be doing on the bigger scale and building it into the portfolio of our infrastructure build that we're doing. Was there a question back here? No, nope, right there. Oh, Glenn, okay. They're pointing at you, Glenn.
So what regulations make you do all these things?
What regulations made us do all these things? Nothing.
Oh, in this profession, we could do things
We did not work
beyond the
this out ahead of
regulations?
time. I'm sorry, Glenn. What?
So in this profession, we can do things that go beyond the regulations? We have
Yes.
so many of our colleagues that say, well, my job is to meet the regulations.
Right.
That doesn't have to be the case, does it?
No. What Glenn's referring to, a lot of wastewater and drinking water utilities have the blinders on, so we'll only do what we have to do when we have to do it. And of course, if you look at that change stuff that I talked about at the beginning, you'll never get ahead of the curve because it takes time for regulations to catch up with the real world. And so there were no regulations that required us to do this. We actually worked with our great Department of Natural Resources, and I remember, I really say that truthfully, even though Russ is here, but they've been a phenomenal partner for us, and we actually put green infrastructure into our permit so that we were required to do it. A lot of that was for the public acceptance side of what we're doing. So there was no regulation on any of the energy. We have to meet air permit requirements and that type of thing, but nothing that said you had to go renewable, nothing that said it had to be self-produced. And on the green infrastructure, nothing required there. We have no consent decree. A lot of utilities my size have lawsuits from the state and federal government saying you have to do something at a certain timeline. We don't have that. We haven't had a consent decree in place since 2008, maybe 2007. Yes, sir.
Have you ever considered hydroelectric measures for renewable energy as a feasible option, particularly in your effluent channels?
Boy, you guys have great questions. We're developing right now what we call our 2050 facilities plan, which is telling us what facilities we need to build for the year 2050. And at the South Shore plant, there's a 150-inch sewer that comes out and drops flow into the plant. And we're actually looking at right now whether we can add hydroelectric to that pipe because, number one, it's big enough. Number two, it's got enough flow continuously that we think we can make the economics work. So it's still coming, but we think we can do that. We did look at it in the early 2000s at the drop shafts going down in the deep tunnel. So there's drop shafts that take the water from the upper system down to the tunnel 300 feet below. The problem with that is we don't use those drop shafts except when we have a heavy rainstorm. So it was too intermittent to really make the economics of the hydropower work there. But I think at South Shore it's going to work. Great question. Yes, ma'am. So which is more important, population or climate change? Well, for me, they're both important. So we work with the Sewer PAC, Southeastern Wisconsin Regional Planning Commission, and they work with the 28 municipalities, and they basically tell us what they think the population and land use is going to be for 2035 and then 2050. So we rely on that. I can tell you when we did this in 2008 for 2020, we're pretty close to what those projections were on the population side. If you haven't heard it in my voice yet, I do believe in climate change, and I do tell people I believe in climate change no matter where I'm at, because I've lived through it in 2008 and 2010. And when we're doing our modeling for the 2050 facilities plan, I can't remember, there's various different assumptions that you can make. We are putting an assumption in there for a changing climate. I just don't remember which assumptions we're making for that. So we're building in that changing climate to the 2050 plan. We've already got the population land use projections there, and that'll tell us, do we need more tunnel? How much more green infrastructure do we need? Do we need a new wastewater plant? We don't need a new wastewater plant. But all these different things are on the table that we're looking at. Yes? So the question is, are there any limitations to going further with the energy production or getting to 100% on the capture of water? The easy answer is money. It's back to those first slides. We're not investing enough as a country in water, wastewater infrastructure. And I think as we start connecting the dots like you're doing today between food, energy, water, that will start opening the door to a broader discussion about investment. But there's no technologies that we're using right now that are, something that's just coming off out of the universities right now. This is proven technologies. We just don't have the money to do it because we're doing a lot of other things too. Michael?
Similar to the gentleman's question back here.
Do you know the answer?
No.
Oh. I don't either.
Well, it seems like about a year ago there was some press about MMSD really almost getting penalized for producing their own electricity. And that, in fact, related to his question, is it more costly to produce your own energy, considering how much you're having to pay the utility for the electricity? So it's almost disincentivized. And so I'm curious where you're at now at MMSD with that.
Before I answer that, Bill, do you know the answer to that question on energy? Bill Farmer? I knew you would. And Bill Farmer works at MMSD. Doesn't work. I can hear you now. Repeat it.
So there's the peak off-peak rates, and the off-peak rate for utilities, as I recall, is around 5.5 cents, and on peak is 11 to 12 cents
Okay.
per hour. Then there's the demand charge on top of that. So our production is right around 5%.
Okay. There you go. I should have looked at Bill first. I told you earlier I'd call on someone in the audience. And the demand charge that Bill mentioned was what was in the paper before. So we actually pay We Energies to have the privilege to take their energy when we need it. And if we don't need it, we still pay for that privilege. But we have to have it because you have to have power to run the plant. So if we had a total blackout or something happened to our system. So that was what the disincentive was, where it's a huge number. I can't remember the dollar amount that we're having to pay. So, but you build that into your models, into your economics. Okay, both. Okay, we'll start here and then go there.
Well, I was just wondering what the water temperature is for that triathlon.
You recognized it. Yeah, I always show this picture back in the bad old days of 2003, 2004. I had a state legislator tell me that the water was so dirty in Milwaukee, how could you live there? And now for the last 4 or 5 years, the triathlons come, and it's based out of Colorado. And they've told us it's the most pristine urban water environment that they've experienced with their effort. So you see all the people lined up all the way around. It's amazing. So I do that just to poke an eye at. He's not in office anymore, and I won't say his name, but I poke an eye at him. The water temperature, well, you were saying last weekend it was 40 degrees. It's not warm. Lake Michigan's always pretty cold. Last question.
So you mentioned Milorganite drying, which I know is pretty energy intensive. Do you know how much of that is currently powered by renewables, or are you at 100%?
Bill? I don't. It's hard to say because we just started. Yeah. Right. So right now, on the landfill gas, we're getting about a third of the energy that we need to produce for the energy requirements that we need. We have a negotiation going on right now with another provider, another landfill, for more landfill gas. Once we get that, I think it'll be at 100% probably. But right now, I don't, because we're taking waste heat off the natural gas turbines, the landfill gas turbines, and then we're still purchasing natural gas to supplement. I don't know that percentage. Thank you very much.
Thank you very much, Kevin. We turn our attention now to groundwater. Unsustainable use of groundwater continues to be an important concern at the state, national, and international levels. Here in Wisconsin, testing has shown that groundwater in various parts of the state is contaminated with elevated levels of lead, arsenic, radium, molybdenum, nitrates, and bacteria, among other things. This session will explore some of those developments. Our speaker for this is Dr. Jared Bales, Executive Director of the Consortium of Universities for the Advancement of Hydrologic Science, located in Cambridge, Massachusetts. Before that position, Dr. Bales had 30 years of experience with USGS, most recently as its Chief Scientist for Water. We're very fortunate to have him with us today, and we look forward to his remarks on groundwater's role in the Nexus. Dr. Bales, welcome.
So my dad's first job out of college was with Alice Chalmers, back when Alice Chalmers was a thing. And so I was born in Milwaukee a while back. I don't think I have been back in Milwaukee. I've been in Wisconsin many times, but not Milwaukee since I was about 2. So I appreciate the invitation. This is this presentation is a little bit. It's national. It's global. It's not particularly local, although I do talk some about Wisconsin issues. And so it's a science-based talk. It's about the resource as opposed to kind of the last talk, which was focused on the engineering aspects of water primarily. As David said, I'm with Quasi. Quasi is a consortium of universities both in this country and internationally. UWM is a member of Quasi. Marquette, I just signed the letter last week approving their application to Quasi, so I'm among friends here. We invite you to look at our resources. We have many resources for researchers and for graduate students. So this image is from the GRACE satellite showing groundwater declines in many parts of the country. And so I wonder which button here do I push? The one on the right. Got it. All right, so just to set some context, and Kevin had a lot of facts and figures, many of which I have in my talk, so I'll just kind of skip by them. But to set some context, this is from the World Economic Forum. So this is business leaders from around the world, not scientists, not wastewater engineers, but people who are worried about the bottom line. And so they put out this report every year on likely issues that the world may be facing. And for the last several years, water has been one of the top crises. And so on the vertical axis is the likelihood of an event, and on the horizontal axis is the impact of the event. So if you're up in the upper right corner, it's not a good thing. And so we see that the World Economic Forum has identified water crises, failure of adaptation to climate change, and involuntary migration as big issues facing the world. Involuntary migration is caused to a large extent now by water and food crises. In fact, there have been papers published that identify the cause of the Syrian civil war from a long-running drought. That drought precipitated the conflict, which has now spread regionally to even globally. And so but many people think that this event was precipitated by a drought and food shortages. And so there are a number of global water issues, and many of them relate to food production. Agriculture uses about 70% of global water consumption, but we need to grow more food. And so, climate change adaptation, water management, it's an engineering issue, it's a policy issue, but it's also a moral imperative. And so I'm glad to see the discussion on ethics later today about this. And so I want to just, if you don't make it through the whole talk, give you kind of what I think are the key takeaways here at the beginning. First of all, groundwater declines in this country and globally are significant, and they are increasing, in fact. Groundwater withdrawals affect surface flows. Not always apparent, not always readily appreciated, but groundwater withdrawals affect surface flows, and I'll show you some examples of that. But groundwater does respond to management. We see places in this country where people have put into place policies that, in fact, have resulted in rising groundwater levels. Most recently, just in the last couple of months, the USGS published a report on brackish groundwater resources in this country. And so brackish groundwater is about 10,000 milligrams per liter of solids or less. Seawater is about 35,000. So brackish groundwater is a resource in this country that's of growing importance. It's easier to treat than desalinating ocean water because of the lower TDS. It's pretty much everywhere in the country if you go deep enough. And so part of the issue is, how deep does one have to go to recover this resource? Another piece of good news is that water withdrawals in this country declined in 2010, which is the most recent reporting period, relative to 2005, and have been some of the lowest that we've seen in the last 50 years. That could be because of the economic, the Great Recession, or it could be because of, in fact, we're using less water. Once contaminated, groundwater takes years to decades to recover. It's not something that we can fix overnight, that we can treat. The water intensity of food varies pretty significantly, I'll show you. And there's a global trade in what people call virtual water. So virtual water is, in fact, the water that's incorporated into a food product. And so if you grow irrigated corn in Nebraska and ship it to, sub-Saharan Africa, you're shipping water to that country, in effect. And so there's a global trade in virtual water. The other thing that's a little distressing in many ways is that many of the clean energy technologies are more water intensive than kind of the dirty technologies. And then lastly, there's a growing effort in this country and globally to make water data discoverable and usable. So it's difficult in this country and internationally to get the water data that we need to make good decisions. So groundwater occurs in different kinds of formations. It occurs in unconsolidated material, which much of that underlies Wisconsin. It occurs in the fractures of bedrock, and it occurs in karst terrain, which is limestone terrain, which has large solute cavities. There's no underground river. There's no underground lake. At USGS, I would often answer the question about, what about that great underground river that flows from here to here? Why aren't we using that? But there's no such thing. Groundwater accounts for about 50% of the water supply in the U.S. About 98% of the water that's used by homeowners who get their own water is from groundwater naturally, just from domestic wells. About half, 42% of the irrigation in this country is from groundwater. Much of the irrigation in Central California, despite the groundwater declines there, is from surface waters that have been shipped down from the north. Asia accounts for about 70% of the globally irrigated land. There are 20 million wells in South Asia, which is essentially India, and there's tremendous groundwater declines in that part of the world. And because of climate change and the potential reduction of flows from glaciers, that region is very vulnerable to water stress. So this image is from the GRACE satellite again. GRACE is a satellite that NASA launched about 15 years ago, and so it measures the very small changes in gravity. I mean, that's the actual measurement. And so if the mass changes, then gravity changes. And so the scientists are able to convert that change in gravity to a change in mass, which then they use to estimate changes in groundwater. So it's a long way from the measurement to the number, and the values are at a kind of a 400 kilometer pixel size, so they're not at the level at which we can manage groundwater. But nevertheless, this global look at this resource has been very important. And it's identified, for example, the places in India and in the China Northern Plains where there are significant groundwater declines. But it's interesting in this particular image, if you look at the larger image, 2003 to 2013, you see one story. And if you look at the 1980 to 2009 image of India, you see a different kind of story. Some of the numbers, because the satellite hadn't been up since 1980, some of those numbers are hindcast or modeled, but nevertheless, looking at different periods, you see different stories. In the U.S., groundwater is declining in essentially most of the major aquifers. In this study, 40 aquifers around the country were evaluated. These aquifers were places where groundwater models had been developed, where water levels had been measured. And so the total depletion in the 20th century and into the early part of the 21st century was about the volume of Lake Erie, 1,000 cubic kilometers. So, of course, we have the highest depletion in the Ogallala Aquifer, or the High Plains Aquifer, where much of the Corn Belt is. But what's surprising to me is the decline there in the Mississippi River Delta. Those are places where we get, and in the Georgia southern coastal plain as well, these are places where we get 40 or more inches of rain a year, but nevertheless, people are pumping groundwater, pretty hard. And so the reason why is because the increased yield in their crop outweighs the cost of pumping groundwater. And Central Valley of California obviously is a big user. They've been a big user since the drought. And there's been a pretty significant increase in groundwater withdrawals. So if you look at, again, essentially the 20th century, this is the rate of groundwater depletion. So the average for the century was about 9 cubic kilometers a year. For the last decade, it was about 25 cubic kilometers a year. So the rate of groundwater depletion is increasing in this country. That's not good news. The good news is, however, that water withdrawals, sometimes termed water use, but it's really just water withdrawals, declined, as I mentioned, in 2010 relative to earlier periods. As the population was growing, the withdrawals for public supply declined in 2010 and were some of the lowest in the last 50 years. And so this tells me, and it should tell you, that water management practices work. That even though we have a growing population, we have a growing economy, our withdrawals have declined. Now, part of the reason for those declines have to do with thermoelectric power generation. The single largest user of water, or withdrawal of water, is for cooling thermoelectric power plants. Well, new regulations and new technology are requiring that power plants use continuous loop cooling. And so instead of pulling the water out, using it for cooling, putting it back into the stream, that water is used over and over, and so that reduces the amount of water that is withdrawn. And so a big part of the reason for the lower withdrawals is because of that particular technology. I looked at Wisconsin, and it seems that many of the plants, maybe the majority of the plants in Wisconsin, still use the once-through cooling. So this just shows the principal aquifers around the country and where groundwater declines are the highest. The bars, the horizontal bars, show the withdrawals, and the two bars with the arrows are in Wisconsin, the glacial sand and gravel, which is a shallow, productive aquifer, and then the Cambridge, which is a sandstone aquifer. And so relative to national depletion, it's pretty high in these Wisconsin aquifers. So back to food and water. So this map shows irrigation across the country, and as I mentioned, about half of the irrigation water, of the water used for irrigation, comes from groundwater. Each dot on here represents 10,000 acres of irrigated land. And so again, if you look at the Mississippi Delta region, South Georgia, South Florida, even into Illinois and Wisconsin, and you see places where you would think there would be sufficient water to grow productive crops, there's a lot of groundwater withdrawal that's going on. This is Wisconsin, a map that I pulled from the web showing the high-capacity wells in the state and the growing development of these wells, and most of it, as you can see, is used for most of the water is used for irrigation. If all of these wells were pumping at 100,000 gallons a day, that rate is equivalent to about the annual average flow of the Milwaukee River at the mouth. So it's a significant withdrawal. And so groundwater pumping and stream flow. So this is an example from that Mississippi Delta region where I showed there was pretty significant groundwater declines. And the upper chart is just the groundwater depletion. And so it really started up in the early 80s. And the lower chart shows you the lowest stream flow that occurred annually in the Sunflower River, which flows through that region. All right, and so the two arrows correspond to the same time, and so whereas the lowest annual flows back 50, 60 years ago were around 100 or more cubic feet per second, now the lowest annual flows are on the order of 10 or 20. This is directly because of groundwater withdrawal. I can show you other examples. For example, in Nebraska, the Platte River, where there used to be an annual hydrograph and a peak in the in the late spring, and now there is no peak because of the groundwater declines. And so we often hear about safe or sustainable groundwater withdrawals. Well, we've known for 70 years, C.V. Tice said in 1940 that if you pull water out of the ground by a well, there's going to be a loss of water from somewhere else in the system, either stream flow or groundwater. But groundwater is, when you pump a well, groundwater always is being mined. So this concept of safe yield perhaps is not, we shouldn't be thinking about that. If you're pulling groundwater out of, if you're pumping groundwater, you're affecting the surface system and you're affecting the aquifer as well. And we didn't used to think so much, we didn't used to care so much about maintaining stream flow, but now we understand how the ecosystem depends on that stream flow maintenance. And so, there are multiple impacts from groundwater withdrawals. I meant to say at the beginning, Tice, that reminded me that in fact, groundwater hydrology, the kind of the field of groundwater hydrology really started in Wisconsin, at the University of Wisconsin, in the late 1800s. There's a nice article in the journal Groundwater that talks about the history of groundwater hydrology and the role of the University of Wisconsin at Madison in that. And I wanted to talk about that a little bit more, but I was afraid of running out of time. So what happens when we pump groundwater? So, if we're looking on the left, we have the pre-pumping conditions, and so groundwater water is recharged at the surface. It flows to a stream, or it flows to a deeper aquifer. But then, if we pump a well, then we change the flow patterns, right? And so some of that water that was flowing to the stream is now captured by the well, and as we continue to pump, we capture more and more of that water, and eventually we have reduced discharge to the stream from groundwater, but we also have an induced recharge at the surface. So recharge at the surface increases. The thing to note is that you can stop pumping today and depletion continues for years to decades. There have been some studies and simulations, model simulations, that show that. If we look nationally at the dependence of streams on groundwater, this is a study, 54 streams. The groundwater contributed anywhere from 15 to 90% of the annual stream flow in a stream. The average is about 50%, right? So groundwater is a very important component of stream flow. If you look, at the sea area, sand and gravel aquifers, through which water flows pretty quickly, the percentage of groundwater contributing to the stream flow is high. And so this is what happens. This is the Santa Cruz River in Arizona in 1942, an unpumped, unstressed system. It's an arid southwest, of course, but this is what it looked like in 1990 after groundwater had been mined. There was no more stream flow, in essence. The riparian vegetation was gone. It was a dramatically altered landscape. Now, that doesn't happen everywhere, but some level of that will happen when we pump groundwater, and it affects stream flow. The other interesting thing about groundwater pumping, and this is not exactly groundwater pumping, it's irrigation, but this is the High Plains Aquifer, the Ogallala Aquifer, again, where groundwater is being mined. And so what we scientists have determined here is that groundwater is being pumped, crops are being irrigated, evaporation is increasing, evapotranspiration is increasing, that moisture goes up into the atmosphere, is picked up, moved by the prevailing winds to the east, and precipitation has increased downwind from this irrigation. So an interesting phenomenon that's been observed here in the American Midwest, but in other places around the world. So I just point to brackish groundwater resources, and so here's just showing places where there are desal plants around the country. The blue dots represent groundwater, brackish groundwater, then the others are brackish surface water and wastewater and ocean. And so you see that particularly Texas is using a lot of brackish groundwater, and they're using it to some extent for enhanced oil and gas recovery. And so, you know, hydraulic fracturing uses a good bit of water for that process. Enhanced oil and gas recovery also can use a lot of water, and so brackish groundwater is a widely, you know, available resource, and it doesn't, because it's so deep, it doesn't impact surface flows. And so I think you'll see growing use of that, both for drinking water, irrigation water, but also for these other kinds of industrial uses. You probably know that when you take water out of the subsurface pores, and those pores collapse because there no longer is water, the water pressure maintaining that. And so we see in places like Central California, the Central Valley, where there's been major subsidence. And so the image on the left, the upper little sign, if you can see it, says 1925, and then the sign at the man's feet is 1977, so that's the amount of subsidence that occurred in that period. More recently, we still see subsidence, and so just during the last decade, in this particular location, we've seen, you know, several centimeters of subsidence over a decade. Now, that may not seem like a lot, but if you got a canal, if you got a lined canal, if you got a high-speed transit system, you got a bridge, subsidence is a problem. It's a major problem. And so not only do we see this in Central California, but we see it in places around Washington, D.C., south of Chesapeake Bay, where there's major groundwater withdrawals. And so the impact there is, well, the subsidence is less, but the impact is on flooding, right? So that area is susceptible to sea level rise. It's susceptible to what we call nuisance flooding from extremely high tides, as well as from surface flows. And so the land sinks a little bit, it's more vulnerable to flooding. But there are places around the country, as I mentioned, where groundwater levels are rising because of either management or changes in precipitation patterns. This example is from central North Dakota, where groundwater levels are rising. There are places particularly along the Atlantic coast, where people were using groundwater for water supply because the surface waters weren't particularly good, black water kinds of streams. But they've recognized that use was unsustainable, and the water levels are in fact recovering. Groundwater is a reservoir for during times of drought. Drought is not particularly predictable. It can occur anywhere in the country or on the globe at any time. It can last from a season, like we had the flash drought in the Midwest in 2012, to a number of years, the drought in California, to decades when we've seen mega droughts in the historical record. And so groundwater is an important resource for us. It's a reservoir during times of drought. If we, of course, deplete that resource during times of plenty, then we have less available for drought. But we do know that the climate's changing. I don't like to say I believe in climate change because that makes it a matter of faith. I accept the science that the climate is changing, and it is, and we know why. We don't necessarily know the implications of that. But one of the things that we see currently in this country, in the instrumental record, not in the model simulations, but in the instrumental record, is that there is no apparent trend in drought occurrence in this country. This curve is just a metric of dryness, and we see no apparent change in that over the last century. Could change, could be places, if we looked at it regionally instead of nationally, we might see a different story, but right now, this is what we see. David mentioned groundwater contamination, so this is again just focused in on Wisconsin. These are places on the left where atrazine has been detected at any level in wells in Wisconsin. The greens are actually non-detects. The blues are below the health standard, and the oranges are at or above that health standard. So it's there. It's primarily there in the places that are heavily agriculture. We also see nitrate in groundwater wells. So nitrate above 10 milligrams per liter, causes the blue baby syndrome. And so these are places in townships, actually in Wisconsin, where nitrate is greater than the 10 milligrams per liter. The colors represent the percentage of wells at which this greater than 10 milligrams per liter concentration was detected. And again, it's kind of, the hot spots for both atrazine and higher nitrate are in the same parts of the state. David mentioned arsenic in wells. Well, arsenic is a naturally occurring contaminant. So arsenic's in rocks, right? So that doesn't necessarily mean that we're doing anything wrong on the land surface when we find arsenic. And arsenic is a bit sneaky, right? Because if you drill a well and you start drinking the water and it tastes good, then you may or may not, people may or may not get their wells tested for arsenic. And so this is a particularly issue internationally. It's not so much in this country, but nevertheless it is a major issue in Bangladesh and eastern India. And we can see that there's clusters here of where we have higher arsenic. Well, it's because of the formation in which what the water comes from, and so what it picks up. The other issue here is this galvanic corrosion. All right, so Flint was not really, my view, but it was not really a bad water problem. It was a water treatment problem, and so the water was corrosive, and as a result, the lead was leached from the pipes, and then it had the health effects. Okay, so this is a naturally occurring phenomenon. This susceptibility to corrosion. This is a particular index that is calculated to give an indication of susceptibility to corrosion. And so this, again, is a naturally occurring phenomenon, but that we have to be aware of in terms of water treatment processes. Contamination is long-lasting. Once the contaminant is in the groundwater, the contaminant that's recharged with, from the surface. And so this is an interesting plot that I like to show. So it's showing nitrate concentration in groundwater at a particular study site. I believe it's in the Delmarva Peninsula in Maryland, Delaware. So the blue is kind of a shallow groundwater. The deep is, or the red is deeper groundwater. So deeper groundwater is older. So if we plot the concentration versus the time at which the well was sampled, we get the image on the left. But if we age date that groundwater, if we use isotopes to tell us when that groundwater was recharged, we see a different story, right? And so groundwater that was recharged in the 40s and the 50s and the 60s, in general, didn't have a lot of nitrate. But groundwater that was recharged, more recently from the 70s onward had a lot of nitrate. Okay, so if you're thinking about, Delmarva Peninsula, we're trying to clean up the Chesapeake Bay, so we're implementing best management practices on the land surface that say, okay, we're going to reduce nitrate that we put on the land surface. Well, we're still dealing for decades with this residual nitrate contamination that flows eventually to Chesapeake Bay, and so people get sort of management fatigue. I'm doing all this stuff, and I'm not seeing any change in the surface water conditions. And so, but this is why. And the formations in which through which the groundwater flows impacts kind of the amount of time the water moves through there, and it impacts the amount of time before we see effects on the surface water system. And so we see in kind of the unconsolidated aquifers, the sandy aquifers in the coastal plain, the groundwater, a fourth of the groundwater in that system may be older than 50 years, whereas in the uplands of the watershed, which is more fractured rock, there's not much groundwater that's that old. So it tells you the kind of issues that we're dealing with there in terms of management. A connection between energy and groundwater, not a particularly good connection, is this issue of fuel spills. So the image, the map, we show both spills, contaminated sites. There's an image of the Kingston, Tennessee coal ash pond spill a few years ago, and so it's pretty dramatic when you begin to plot the number of these spills on a map, either pipeline breaks or spills at the well pad or wherever. And again, this material takes a long time to move through the system, to degrade, decades. Of course, the plot doesn't exactly show the magnitude of the spill. I mean, it could be 10 gallons up to millions of gallons of it. Another connection between energy and water, and I hope you know this, but if you don't know it, I hope you know it after today. Bottled water is hugely more energy intensive than tap water. I wish Kevin was here to see this. But, the energy intensity, the kilowatt hours per liter of water is anywhere from 0.5 to about 3 kilowatt hours per liter for bottled water. For tap water, it's 1,000 times less. And the other thing is that bottled water is not regulated. Tap water is, it's tested and tested and tested. So I understand bottled water is convenient and Perrier tastes good, but it doesn't make a lot of sense in terms of the resource. This gets back to that issue about water consumption and the amount of water used for the different kinds of energy, cleaner energy like biomass, biofuels, geothermal, and so on, and the water consumption volume per kilowatt hours of energy produced. And so, so we have two things here. We have the amount that's consumed, and so much more is consumed for coal and natural gas and nuclear because more energy is produced that way. But in terms of the water efficiency of some of these clean technologies, water efficiency is not particularly good. I mean, if you look at geothermal, if you look at biomass, particularly biomass from irrigated corn and soybeans, the water efficiency is pretty low. And so I think this represents a challenge to the community and a challenge to the Nexus, to dealing with the Nexus. So not only is tap water more efficient than bottled water, but our choices on food have an impact on, kind of the water footprint. And so if you look at the water footprint in terms of liters of water per kilograms of food, you see that the water footprint for beef is much greater than it is for fruit and vegetables, even for irrigated corn. And so, but we're seeing in the world a move to higher protein diets to beef and pork and chicken, and so this has an implication for our water use. And so this is just a longer list of water intensity of the product, and beer has a pretty low water intensity there, for example, compared to beef. So drink more beer maybe, I don't know. One of the good things that is happening around water and water issues is this at the federal level, and it's trickling on down, is what's called the Open Water Data Initiative. And so a number of federal agencies are involved in that. A number of other kinds of NGOs like Quasi and Pisces Foundation, the Aspen Institute, are all involved in this. But in 2013, the president signed an executive order, and we know those can be rescinded with the stroke of a pen, but he signed an executive order that said kind of the default for federal data is that it's discoverable and it's machine readable, right? So any data that are collected using federal dollars, so that's NSF dollars, that's USGS dollars, that could be EPA grant dollars, any of those data should be open to everyone and discoverable through the internet. Now, implementation of that's a challenge, but nevertheless, agencies are pushing forward on this. It's difficult as a hydrologist or a scientist to develop a very tight water budget for any watershed in this country. So, if you take the water going in from all the sources for the watershed and the water going out for, natural and human uses, it's pretty much impossible to do that. And so how do you manage your bank account if you don't know what's coming in and what's going out? And how do you manage your water if you don't know what's coming in and going out? Another good thing that's happening across the country now through the NGWA, National Groundwater Association, through ACWI, which is a federal advisory committee on water data, and others, is this National Groundwater Monitoring Network. So groundwater data often can be difficult to find. Groundwater levels are measured by many entities. This network says, okay, we're gonna bring these things together virtually. You collect your data, you agree that you're going to collect them to some minimum level of standards, but the data still sit on your computer. We're not pulling them all in, but we're going to make these data accessible to everyone. And so there are grants to states now that support state efforts and others to bring their data into this network. This is the current network. But it's growing, and it's a very positive thing in terms of groundwater management. The thing about data, though, is that the data can disappear at will. On data.gov, at the beginning of the year, there were about 200,000 distinct data sets, and they're all over the map in terms of the kinds of data that are there. The Washington Post reported this week that there are now about 150,000 data sets on there. Now, some of them probably were pulled down because they were old. Some of them might have been, combined and so on. But data are a precious resource in terms of managing water. So that's what I have. Thank you. This is an image of groundwater flooding in in England. We do get groundwater floods. I think you probably get some here as well, and so a nice image. Thank you. Yeah, so I think there are a couple of issues there. Water management is a local issue, and so Kevin put up the picture of the rain barrel and talked about how that was a great water storage device in this region for people to use. It helps with runoff. Well, in Colorado, rain barrels are illegal because of kind of the prior appropriation law and how water is managed there. So that rain should come off of your property down to mine. You can't capture it. So the same is true with groundwater. Groundwater is managed at a local level. And so there are places in the country, for example, California just passed, I think a couple of years ago, the SGMA law, and I can't remember what SGMA stands for, but GMA is groundwater management areas. And so they're recognizing what's happening to groundwater in California, and so they're trying to implement these management areas. Nebraska is very good about managing their groundwater. They again have management areas, and so, but then it's also a bit of a land rights issue. I mean, I've been in meetings where people say, that water is under my land, and it's mine, and I'm going to use it, and so that's a school of thought there. And land rights issues, are a touchy subject in this country. The technology is improving dramatically, and so I think, I mentioned earlier that irrigation use has actually declined in terms of water per acre used, and so that's because the technology for applying water has improved. The cost of that has come down, and so as producers look at the trade-off between buying that new equipment and pumping more water unsustainably, then they invest in the new equipment. The other thing that's happening is kind of a revolution in sensors, and so many producers have sensors, soil moisture sensors, rainfall measurement, and so on throughout their cropland, and so they can apply water much more judiciously than they have in the past. But in terms of regulations, it's a little bit of it depends on where you are.
Oftentimes perception and reality are two different things, and I'm curious about an article I read a couple of weeks ago about Lake Mead near Las Vegas. And the perception would be that Las Vegas is the cause of the problem and they're using a lot of water. And in fact, they're doing a lot to reduce their water usage. And the problem is coming from upstream. When you talk about the impacts on surface flow because of groundwater use, I'm curious what you would say about the future of the Colorado in the coming decade or so.
Right, so there has been a study on impacts of groundwater withdrawals in the upper Colorado, and I can't quite cite the numbers, but there has been some work done on that. Las Vegas, they're an innovator in my view in terms of urban water use. They've done a lot of good things. Now, they've also been aggressive in seeking new sources, groundwater sources from up in Utah, for example. And so, based on the historical record, Lake Mead the region has gone through droughts in the past and has recovered. But with water withdrawals increasing, with temperature increasing and evaporation as a result increasing, it's going to be tough. Lake Mead and Lake Powell were designed based on water data collected primarily in the first 2 decades of the 20th century when conditions were wetter than normal. And so the design was based on, perhaps faulty assumptions about what normal flows are. So I think it's going to be a struggle to get back to the levels that Lake Mead was at. But that's just that's just Jared's kind of fuzzy crystal ball. But water use is increasing, evaporation is increasing. I mean, the amount of water that comes off of those systems from evaporation is tremendous. There have been proposals to, put little balls on the surface of those reservoirs to reduce evaporation. So I think it's going to be a continuing challenge in the Southwest to provide water.
I think we'll have to stop there. Please join me in thanking Dr. Bass. Okay, so we have arrived at the time for our first break. Just two quick announcements. First, we will start up again at 10:35 with our morning panel, so please make sure you are back on time for that. And second, if anyone here is interested in receiving a certificate of attendance for claiming professional development hours or anything like that, I'll have a sign-in sheet at the front desk here if you could stop by and just sign up with your name and email address. So I'll see you back here at 10:35. Thanks. Okay, I think we're ready to reconvene and move forward with our morning panel. Our first discussion will provide additional perspective on the various aspects of the Nexus and also respond to what we've heard this morning from Kevin and Jared. The moderator for this panel is Matt Magruder, the Environmental Research Manager at the Milwaukee Metropolitan Sewerage District. In addition to his work at MMSD, Matt is central to various regional planning efforts and also serves as vice chair of the NSF IUCRC that I mentioned this morning as the sponsor for this event. He's very well suited to lead this discussion, and so I'll turn it over to Matt and allow him to introduce our panelists for this session. Matt?
Thank you, Dave, and thank you all for having me here. It's my privilege to moderate this session. I hope we all found the morning plenary sessions to be as thought-provoking as I did, and hopefully can turn this into some great open discussion with some very qualified panelists that I have the privilege to be speaking with here today. So with that, I'd like to start introducing, and I'm not going to go in order. I'm just going to kind of go in order of the how our bios are presented in our handout packet, and I'm not going to put you through me reading them word for word, but just briefly, I'll start with Pinakin Desai. He's the managing engineer for Metropolitan Water Reclamation District of Greater Chicago. It's always a mouthful trying to get through that, but a great engineering name. He's responsible for energy management at all MWRD facilities, where he has made significant impact in lowering their energy costs and also reducing their energy usage. He's also responsible for maintenance of 4 water reclamation plants, very impressive in nature. I'll also go with Dr. Glenn Diger, currently professor of engineering practice, University of Michigan, president founder of One Water Solutions, LLC, a water engineering innovation, previously serving as a vice president at CH2M Hill, where he was employed for over 35 years. Very impressive career. And then finally, Russ Rasmussen, somebody we hold very dearly here in Wisconsin, our regulator. He's been in the game for a long time. I know my father had great experiences working with Russ and his staff at the Wisconsin Department of Natural Resources. Long-term employee, served in the state for the last 25 years. Russ has received a Bachelor of Science degree from UW-Madison and a Master's of Business Administration from Edgewood College in Madison. So he first served with the administration of Transportation, and since has been with us at the Wisconsin Department of Natural Services. And he has been wonderful and tremendous in helping MMSD get its goals into our permits and helping advance our region in terms of water quality. So I want to thank you all for coming out today and being here. And again, thank you to Marquette Law School and NSF IUCRC for sponsoring this and for all the hard effort put into it. Want to just take care of some brief housekeeping from Dave and Brian Weigel at Wisconsin Department of Natural Resources. This was just a fantastic opportunity, and I want to thank you for your hard work pulling this together. So with that, I will begin. I wanted to kind of build a good question bank off of some of the presentations that we just saw, and I found some common similarities, as I'm sure you all did, between some of the statistics that were shared from both Mr. Schaefer and Dr. Bales. As stated on both of their presentations, roughly a third of all counties in the lower 48 states are going to face higher risks of water shortages by mid-century. And as a result of global warming, what types of conservation practices are being implemented? And so as a precursor to the question, I just wanted to allow each of the panelists to kind of briefly introduce themselves and their agency, and then kind of go into what types of conservation practices they've implemented or are planning to address with the specific risk of water conservation within their industries or the industry that they represent, or what they advocate for, if that's more of the role. So with that, I'd like to start, go left to right here, from my left to right, start with Mr. Rasmussen. If you could just go into, a little bit about yourself, what your agency does, and then kind of what you're doing to address some of these water conservation issues that we're going to be seeing become more prevalent in the near future.
Does this work?
Yep.
Okay. Thanks, Matt, for that introduction, and a warm thank you for having me go first. I've been working with the Wisconsin Department of Natural Resources since 1999. Before that, with, as Matt said, a couple other agencies with the state, and started with a short stint in waste management, then but quickly went into the runoff management section, which runs our KFO program, does that permits, does non-point, does stormwater, and then became the director of the Bureau of Watershed Management, which essentially did everything regarding water except for drinking water and groundwater. But we did all of the different permits, all the different point source permits, as well as, again, the same aforementioned KFO and stormwater. We also set the water quality standards for the state, and we also set, I think it was Kevin was talking about TMDLs, and so we established the impaired water list and that. So had quite a bit of activity there, and then following that, for a short stint, I was the deputy administrator of the water division, so that included everything water, and then the division administrator for a short time, and then with the reorganization of the department, the water division was eliminated and subsumed into actually 3 different divisions, and so I've sort of evolved into a policy advisor to the secretary, and am involved in a lot of different projects. In fact, in my current job description, the most controversial projects faced by the department. And of course, those are hard to find because we, in the Department of Natural Resources, don't do anything controversial. So, having said that, you talk about conservation initiatives. I'd like to talk a little bit about something that's currently going on, and because I think it has some impact and relevance to the food, water, energy nexus. And that is something that's actually being headed up by our Public Service Commission, where they are looking at a concept whereby we would promote not only digesters at farms, but also water treatment facilities in conjunction with that, and hopefully innovative manure management practices. And so we've got currently a request for a proposal out for that. And at first I was somewhat pessimistic that we would get much participation. I've become more optimistic lately because I have heard from several sources. I would expect that we will get at least 2, maybe 3 or 4 proposals, whereby you would have people forming consortiums, because you're not going to have any one expertise in one. CH2M Hill isn't going to have digester, water treatment, manure management, all in one place. You're going to need consortiums, and you're also going to need farmer participation, agricultural participation as well. And we've tried to keep it very broad as far as whether there would be like a hub and spoke system where there would be a regional digester, and we are looking at multiple farms. But I think what's really important is that not only are you going to get electricity produced or natural or gas, methane gas to put into the system, and the focus on energy, which Kevin talked about some grants, is helping to fund that portion of it. My and our interest, of course, has been on the water quality piece and on maybe some innovative manure management. And so the treatment of water, and to their credit, the impetus for this has been in issues that are groundwater issues in karst areas that were talked about up in Kewaunee County, I think was the start of it. And Kewaunee County is, for those not from Wisconsin here, is sort of up near Green Bay, I guess is the best way to describe it. And they have shallow soils underlain by karst, very, very heavily karst fractured bedrock. And so just as an example, where we see water, and we have documented groundwater movement in this karst bedrock of 1/4 mile a day. So this stuff moves with very little attenuation, and it's very sensitive to contamination because it's overlain in some areas by very shallow soils, and we have a high concentration of livestock agriculture up there. So that all kind of sort of creates this perfect storm, if you will, that we're looking to address right now. And when we went out and talked with folks about when we were setting up this RFP, and they talked to some of the farm groups up there, they were very adamant about there needs to be a water quality component, or we're not going to participate. So they are very concerned from an agricultural standpoint about this as well. So I think it offers some opportunities. It also offers some challenges as well. And I think you have to overcome some agricultural resistance. You have to overcome some local citizen resistance, as this is something new. You have to overcome some local official resistance, again, because it's something new. But we really think we can realize a lot of volume reduction in the manure, and the opportunity to reuse the water, whether it is through maybe a tea water where you might do some irrigation with that, or we have a system that's actually in place in a county just south of there, which has a digester coupled with water treatment, that they are getting the water clean enough to recycle to the cows. And so, and they're experiencing a 70% reduction of their water volume. So, but that also offers opportunities for new manure management, because the way the system does, it goes through an ultrafiltration, which takes most of the phosphorus out. It goes through an RO system and a deionization system, which takes most of the nitrogen out. And then it goes through ultraviolet system, which kills the pathogens. But the fact that it takes out the phosphorus first and the nitrogen second in a kind of a separate system allows maybe for some customization of what comes out to create a fertilizer that is, say, suitable for corn or suitable for whatever you're planting, so for whatever your rotation. So I think that that's the type of thing that you're looking about conservation practices. You're producing energy, you're producing you're reducing your dependence on water. You're more effectively, more efficiently using it, and it allows you maybe some optimization of your nutrient management and your manure management. So that's the type of thing that I think we need to be looking at. I could talk a lot more, but I will save some time for my colleagues here. So.
Well, thank you for that very thorough answer. I'm going to turn it over to Dr. Glenn Dagger. And first, please introduce yourself and a little bit about what you do at your organization, and then as you move forward into the types of conservation practices you advocate for and educate those up and coming on the issues we're facing today.
Okay, so Glenn Deiger in 2 or 3 minutes. I think the facts of the case are never the substance. So the truth is, I'm a really lucky person. So the first part of that was that I was kind of through my education, but then I was really fortunate to become a water person. And I will tell especially the young folks here that a career in water is a wonderful career. That you have the opportunity to help people, you have the opportunity to do really interesting things, and you have the opportunity to contribute to society, and at the same time you can earn a living that supports yourself and your family. So I don't know why anyone would not want to be a water person. For myself, I've also been very lucky in terms of I'm an intellectually curious person that just wants to go out and do positive things, and I've been really fortunate to to find places to be able to do that. So I've been able to, over my career, I describe it to keep a foot in practice and a foot in academia, or at least in creating new ideas and so forth. So CH2M Hill, where I was for quite a while, was an important part of that. I have been in and out of academia, though, over the years. So, and in particular, over about a 10-year period, I had really a wonderful experience. I was senior vice president and then president of the International Water Association, which in particular has given me a real perspective on water, not only in the U.S., but around the world. So that's a little bit about me. In terms of water conservation and water management, let me say just 2 or 3 things. The first thing is that there's immense opportunity. It's absolutely clear that there is immense opportunity in every sector to use water more efficiently. The data that I'm aware of says that in agriculture, the difference between the best in class and the worst in class is 7-fold. And we're not talking about 5 or 10%. We're talking about nearly an order of magnitude in terms of water efficiency. And you look at, one of the most water efficient countries using water in agriculture is Israel. Here, agricultural production and export of not only feeding themselves, but exporting food to Europe in a desert. So, they are, people roundly say that the Israelis are some of the most efficient. They're the 7 times more efficient. So it's not a matter of the lack of knowledge. In terms of industry, I have to say that the progressive industries have done a wonderful job of better and better water management, partly because it pays, but partly because it's how it positions them. So if they're less dependent on external support sources of water, and especially if they don't have to worry about discharging wastewater and someone suing them over that, they're better positioned strategically. And in terms of municipal water use, in fact, water use by us is going down and down and down. And just anytime you buy a new appliance, your water use goes down as well as your energy use goes down. So there's amazing opportunity. But in terms of water supply, the original question, 1/3 of of counties in the U.S. One of the things that we've learned, it's not about supply, it's about resilience. Because the one thing about water is it's never right. We either have way too much or we don't have anywhere near enough. So the answer that's developed around the world, the Aussies really crystallized this in the mid-90s to the mid-2000s during what they call the Millennium Drought, is the idea of the portfolio. So how do you put together a combination of water supplies that perform well, when it's raining like crazy, and also when it hasn't rained for a long time? And that's the answer. So it's not about what happens on the average, it's about how do you manage the extremes, and it's about putting together a combination of water supplies that works well over that range of conditions. And the answer becomes, quite frankly, in many cases, conservation is the first step so that we're less dependent, but then it's reuse. It's reuse is the and that's what you were describing. So how do we take this resource that we have and use it many times? The fact that we've used the water once doesn't change the water. We haven't hurt the water because we've used it. It's still H2O, and all we need to do is to take out some of the things that we've added. And oh, by the way, drinking water is not pure H2O. It actually has, in spite of what some people think and so forth. So it's all about producing, it's all about the quality of the product water and matching it with the use, which is what you were describing. So there is absolutely no reason why anyone on this planet doesn't have a sufficient supply of water. We have the knowledge to do it. It's mostly us and our lack of imagination. I will tell you, I see where people do extraordinary things under horrible conditions. And there is absolutely no reason why there is in terms of what we know and how we can put it in place. So these problems are all solvable. We need more Kevins, and we need more. The good news is that there's a growing number of individuals in water that say, I don't care what the regulations say, and I'm just gonna go out and do it. Guerrilla warfare. So, and when we get enough folks doing that, those that don't want to, their excuses will be gone. That's my theory of change, but we know what to do. We just need to go do it.
Thank you for that. That was a very inspiring talk. As you broke into that, it's always nice to have encouragement, to hear, to have innovation come before desperation. So it's amazing what you can overcome when you can break down barriers and perceptions and stigmas associated with direct potable reuse and other things of that nature. So I appreciate those comments. With that, I'm going to move down the line to Pinnock and our counterpart just south of us at Metropolitan Water Reclamation District. Never ceases to amaze me the sheer amount of customers you serve, and if not the largest, one of the largest reclamation districts in United States here. So with that, I'll turn it over.
You're taking away some of my lines. Well, thank you, Matt. I am very delighted to work for the district. As Glenn mentioned, for the for the students here, yeah, when I came out of school with an engineering degree, electrical, I would have never thought I worked in the water industry. So, but now that I've been working there for a while, I think that for this generation, the next big thing is going to be water and energy. And I think being at that nexus, it's in a great position to be able to change that future to not only reduce water, but also electricity usage. So I've been with the district for about 18 years, 19 years. Started working in their maintenance department. I started moving up, and then about 10 years ago, we started really moving into energy efficiency, trying to reduce energy, but also trying to buy energy at the lowest cost. And we formed a team across the board, different divisions, and for the last 6 years, I've been leading that team into doing both sides of the energy portfolio, meaning not only doing efficiency, but also trying to procure electricity at a much lower cost. And I can get into that a little later. Going back to Matt's question about, reuse, as your director said earlier, we're doing a lot of things that MMSD is doing. One of the biggest things for water reuse is all of our locations use a lot of water for heating, cooling, for bearing cooling, and all that water we use is our effluent water. So for a facility like Stickney, which is one of the largest, our average daily usage for in-house is about 6 million gallons. That we don't use fresh water, we use our effluent water for our own process. So it does start from home. We try to do it ourselves. And then we also try to partner with other industries that are close to our plants that can also use our water for their cooling purpose, so they don't have to use clean water. Other programs that we have, which MMSD mentioned earlier, was rain barrels. We've been doing rain barrels for a few years also, and it is a great way to reduce stormwater. As we know, like last night when it rained, we all look at how much rain is coming in, how much we have to pump and get all the facilities up. Every gallons of water that we don't have to treat, we can reduce the footprint of our plants and reduce carbon footprint. So rain barrel. We also have another program where we started a couple of years ago, which is we call it Restore the Canopy, where we're giving out oak trees to communities and individuals. Our survey says that one oak tree can save about 2,800 gallons of water a year. So, if you do get a lot of participation, you could change how much groundwater you do get from storms. We're also teaming up with other entities like Friends of Chicago River, where we're trying to educate people on Overflow Action Day, where if we know that there's going to be a lot of flow coming into our system, they would educate people on saying, okay, today is the day. Like, we've seen the ozone depletion days and things like that. We're trying to work a day that would be for Water Conservation Day and start people thinking into conserving water. So those are things that we've also done. Permeable pavement. I think some of the things that, and like you said, Glenn, I think education is there. Implementation is something that we need to work on, and we're starting to do a little bit of that. But I think as it gets along, more and more people get involved. I think it will someday. We'll have a lot more conservation.
Thank you for that response. Just for the sake of time, I'm going to try to get through a few questions more before we try to open it up to the audience for some questions. And if there's time, I'll continue to barrage you with mine. As a research manager, I get the liberty of asking a lot of questions at work, and that tends to carry out in all aspects of my life, whether people like it or not. So I guess I'll start and stay with you on this, Panak. And I've learned through our brief email exchanges that you've done something really innovative, procuring electricity via reverse auction. And with that, I have a three-part question for you. One, if you could maybe briefly describe how that arrangement came about, working with the power utilities that offer service. and then how your ratepayers have benefited from that arrangement, which was probably fairly obvious. But the last part is, if the resulting rates are low, does that process influence decisions made at the agency about pursuing alternative energy, energy conservation, and implementation of higher efficiency infrastructure at your facilities? I know it's a balancing act, fiduciary responsibility, and there's some very impoverished communities that you serve. So if you could just maybe shed some light on the balancing act that has to occur.
Sure. So starting with the reverse auction, in about 2011 is when we found out that we were able to do a reverse auction to buy electricity. And in the simplest term, a reverse auction is very similar to eBay, but you're not buying a product, you're buying electricity. So what we did was in 2011, we started with an RFP to get a partner that could host an auction. And we partnered with a company called World Energy Services, who are now bought by Internoc. What they have is an auction platform, and what we did was we pre-qualified few energy suppliers in Illinois and invited them for an auction. And we ran the auction in 2011. One of the benefits of doing the auction is that we had ability to buy different products as far as power. So we asked for, the gentleman mentioned earlier about peak on peak. I think you mentioned about peak off peak. We were able to get pricing for peak, off peak, and round the clock. We were able to get pricing for 1 year, 2 year, 3 year term. And what that gave us is ability to compare different products and different price points to say, okay, how far as a district we want to go and budget electricity, or how far, what is the risk of buying power for 1 year versus 2 year versus 3 year. And when we did the auction, it was pretty interesting when we looked at the results, how much risk premium you pay for having contracts out more than 2 years. Mm-hmm. And we found out that from our first auction that our 2 year was about the price point that we were comfortable with. Mm-hmm. And so we locked in a rate for 2 years round the clock. The other thing we found out was also that we were operating our plants based on peak and off peak, basically pumping more in off peak hours and not. Well, we found out that around the clock pricing was a better option for us, because for 2 years they were locking in the rates around the clock, so we didn't have to worry about it rained, we can't pump, or we have to pump. So it gave us a benefit of going around the clock rate for 2 years. Our first auction, we were able to reduce our energy price by about $10 million a year, which is a great impact. Going back, electricity for our department and as an organization is one of the largest line item on our budget. Besides personnel, electricity is the second largest budget item. So any reduction in that impacts the entire budget of the organization. Mm-hmm. So the $10 million that we were able to save, we were able to put that into maintenance of other equipment. We're also able to justify some of the energy conservation projects. So about 2 years ago, 3 years ago, we did an investment grade audit at all our location. And last year we did our first energy performance contract. And I'm not sure how many people are aware of that, but that's standard, government contracts are more, you're building this, or you're building a product, or you're providing this service, a fixed scope, fixed project. What we did with an EPC is that we're not specifying equipment. All we're doing is that we're holding them to a performance of how much energy they're going to save. So they did an audit for our locations, and we say, okay, for this location, you're going to save 20% energy. Well, we're holding you to that percent decrease, and it's a performance contract. So we're in process right now. We have about a $4 million project at our Calumet location. We're replacing the entire facility with LED lighting. We're also putting steam blankets on our steam loops to save energy. And we're also doing some retro commissioning on our HVAC. We're also benefiting on this energy conservation. We're trying to get rebates and everybody has rebates. So we're trying to, we're getting about $500,000 in rebate from DCEO for this project also. There's a lot of learning curve for us because like reverse auction was the first one at the district, something we've never done before. The performance contract was also the first one that we've ever done. So, a lot of things with energy keeps changing, and we have to change with it, and sometimes governments are a little slow to change. And it took us a few years to get it, but I think once we saw the benefit from our reverse auction, some of the other ideas kind of went with it. And I think, so sometimes just trying to get initial thought through took us a while, but then, our procurement, our law has been a good partner with us in trying to get some of these contracts through. But, besides the reverse auction, we've also reduced our electricity by participating in demand response, where we also save money by reducing our energy when the grid is overloaded. We're able to get over the years about $11 million back just by reducing load, not really impacting our operations. One of the gentlemen asked earlier about hydroelectric. District does have an hydroelectric facility in our Lockport, and last year we were able to do another RFP to sell a renewable energy from Lockport without changing any operation at the location. We're able to capitalize on just selling renewable energy, and we're looking to make about $300,000 a year just by selling renewable energy credits. So we're always looking for ways of trying to lower our energy costs and reduce our energy usage.
Yeah, that's great. And I know firsthand, being part of a government utility, so to speak, you want to be on the leading edge, not the bleeding edge for breaking into new territory. And sometimes it's scary to kind of be in the house that you're building around you. But it's really exciting to see some of the progressive measures that you're doing at MWRD. And I definitely appreciate, and I've definitely learned a lot today from just a few moments of you speaking. So thank you for that. I'm going to go back to Glenn now, kind of touch base on what another common theme that I noticed in some of the slides this morning that went through pretty quickly, but also is something that has kind of struck me over the past few years. The U.S. drinking and wastewater infrastructure specifically receiving a D+ on the ASCE infrastructure report card for 2017, meaning poor, at risk in terms of below standards, many assets being at the end of their useful life. They exhibit significant deterioration, face serious capacity issues in the near future with high risk, high consequences of failure. This is just 2 of 16 categories competing for desperately needed funding. From your perspective, what is the role of academia in training the next generation of engineers to call attention to these 2 specific categories that are often out of sight and out of mind for the general public?
Well, that's a great question, and I think it really gets to the heart of are we training people or are we educating people? And educating people for really for lifelong learning. It's always been the case that lifelong learning has been a part of a professional life for anyone, but it's even more important these days given the pace of change. So, I was thinking, because Matt was good enough to give us these questions, so I was thinking, Kevin, would anyone have thought that about him being an engineer until he commented on it? He didn't talk too much about engineering, did he? He talked about a lot of other things. So, so the issue really is about helping people to understand that once they have completed their formal education at a university or whatever, they're just they're going to continue to learn new and different things as they go forward. So successful professionals all do that. You do get people that say, well, because you need to know so much what one needs. So they ask the question, do we want to educate? They ask the either or question. Do we need generalists or specialists? And actually the best people are both. the best people are both. So there's a phrase that people use about being a T-shaped person. So having depth and breadth to go with it. So so the water team is a diverse team. So this almost sounds like you're asking about engineers. Engineers are just part of the team. So, you know, it takes business people, it takes communication people, it takes aquatic scientists, it takes lawyers, it takes people with a lot of different backgrounds. So when I have a legal issue, I want a good lawyer. But I want, you know, someone that has command of their particular discipline. But then it's about helping people to understand that they will grow and helping them to learn how to learn. And that's an area where we really need to, you know, to improve in terms of the educational experience. So, but I think it's really important to understand that that it's a diverse team, so the different perspectives that are needed come from different perspectives. I will also say the first part of the question about, you know, a D+. You know, ASCE's been doing these report cards for well over a decade, and it hasn't made any difference. So I would ask, why do we keep trying to motivate the public using this approach when it obviously doesn't work? So I would suggest that we might look at what a profession that's been very successful communicating with the public does. I would submit that the medical profession, I mean, the medical profession they get money, they get support. So do they talk about sickness or do they talk about health? So if you see a commercial on TV having to do something with if it was a surgeon, would they show you an operating room? No, they'd show you healthy people. So again, I go back to Kevin, and you know, water is essential for the economy. So if the average person wants to support their family, have a job to support their family, they need to support water. Kevin, that first picture of, you know, the beautiful landscape, the people jumping, you know, the triathlon, water provides the opportunity for people to be together. Water is inspiring to people. So, and we talk about the cost of service. I think part of our problem is we talk about too much about what it's going to take to provide the service, and we need to talk much more with the public about what they're already getting and what more they can get. If only they just like every place we spend money is under assault, but there's some that are doing better than others, and I think we need to take a look at what they're doing and steal shamelessly from them in terms of how they're better communicating the value, because the value of water is much, much higher than simply turning on the tap. It permeates all the way through everything in society. We need to, no one is going to tell that message more succinctly than us, because no one cares more than us.
It's a fantastic response. I really appreciate that. I'm seeing myself at Milwaukee Metropolitan Sewerage District that taking a multidisciplinary approach has been a lot more effective in answering some of the tougher questions that we're challenged with in terms of operating and justification with our ratepayers, and just getting everybody on board and working together seems to be the most effective way in the long run for us. With that being said, I definitely have a few more questions, but I'm going to take a step back because we have 11 minutes left in this session to open it up to all of you who probably also have some great questions. So with that, yes, please, sir. I think you have to hold it the whole time in order to work.
All right, there we go. This is for Matt Panakin, and please, everybody else put it. You mentioned that the speed of government is slow. Guess what? That's not surprising to anybody here. But as you guys transition your businesses from utilities and cleaning water to resource recovery, in some aspects revenue generation, energy efficiency, asset utilization, speed to market is critical. Every time, if you guys take 2, 3, 4 years to get a project done, that's 2, 3, 4 years of assets that the taxpayers have paid that you're not delivering. How can you guys speed up your processes and or integrate with the private sector in P3s or something to deliver projects faster when it comes to revenue and or energy efficiency?
Would you like me to take a crack, or would you like to go first?
I can take a crack on the energy efficiency side. I talked about trying to reduce cost on one side and also trying to do energy efficiency, and the tie between them is relevant, right? So as we reduce our energy pricing, it made us also a tough time for us to justify any energy efficiency projects also. Because our energy rates are so low, trying to justify renewable energy or energy efficiency when we're looking at a low rate becomes even harder equation. And I think for energy efficiency, our financial is really the biggest thing that we run into. But you mentioned like a few other things, which is resource recovery, water quality, and it's really a juggling act between all of those things with a finite budget that we have to work with. So a lot of times trying to balance your projects between those needs and also trying to figure out what regulations are going to come through also plays a role in delaying some of these projects. But energy efficiency, for the biggest delay has been trying to justify financially viability of that project.
To build off that, no doubt it's a slow-moving industry compared to the tech firms that are out there. A lot of times, one of the biggest challenges is it takes so long to get a new technology in place, in part because of the way things always have been, which drives me crazy. A lot of times, you want to see a full-scale implementation at a large plant here in the United States before anybody will give it a chance. So a lot of times, innovators end up fizzling out because of the lack of funding in order to get a pilot demonstration up and running, to get buy-in for it. Result of a lot of firms like ours going out to consulting firms to do some of the design work, and it's at liberty of what gets put into the specifications by the design consultant. One of the things that we're doing, though, at MMSD, and I think a lot of the other, like MWRD, participating in testbed facility networks. That's one of the biggest things I think we can do is open up our doors and try to help those who are bringing technologies to the market, provide with space, power, in-kind services, technical assistance, when possible, funding, cash funding. I think that's what it really takes. It's a collaborative process because as it stands, a lot of times technologies are outdated by the time they're ready to come to market. That's just the nature of it in our business, and it's unfortunate. I do not personally believe it needs to be that way, but I think it takes time. I really do. And, we're trying to work forward with it. I know MWRD is, as well as some of the other utilities, opening up our doors and trying to be progressive, working with our universities. Private-public partnerships are huge. And again, trying to take more interdisciplinary approaches. A better example of a quicker turnaround, faster than I would have expected, is if you look at the local news, some of the work surrounding coal tar sealants and just the incredible loading of polycyclic aromatic hydrocarbons in the products. We built off of research done by USGS, And then we also worked with a lot of NGOs and people who do have the ability to lobby, a voice that we don't have a lot of times in government, and that really expedited and accelerated beyond what our legal staff, beyond what the scientists thought could have been done in terms of legislators and progressive folks on the district's commission making recommendations to support restricted uses within the statutory authority. So the multidisciplinary approach is again, something I'm a firm believer in and growing as well. So hopefully that somewhat answers your question and sheds some light on the things that we're doing. So opening up our doors and encouraging participation and trying to help supplement the need for funding is a big thing. Yes, sir. Yes. Mm-hmm.
So what do you pay for communication services, cell phone, internet, and so forth? What do you pay for that? What do you pay for water? Our problem is that we haven't sold our product.
Yeah, that was one of the questions I was coming at later. Is the cost of energy in the United States, is the cost of clean water too low? It's a tough question. You know, a lot of people believe clean water is a right, and it's definitely a privilege, that's for sure. And it's something that I even personally can sometimes take for granted as I try to remind myself to turn off the water when I'm brushing my teeth every morning, every night. So
I reacted to your question because the search for the silver bullet, which we should not, we should continue to look for. Is there something which will be the game changer? But if we get distracted by the search for the silver bullet, when the answer I think is right in front of us, it just takes some hard work. That is to communicate better with the public, but also, I think part of the answer to your question is if something's going to take time, we better start early. This is not as complicated because I see people that are doing it.
Right.
I see people that are transforming, but it's basically people that don't accept the status quo. People that don't accept the status quo, and then there is a perception that efficiency costs also. Actually, efficiency, you see people, I've been really fortunate to work with a wide range of parties and so forth. So there's some that say, well, if I just get by, it's the least expensive. Actually, those that focus on quality, right? Those that focus on doing it right actually prosper in the long run. Our problems are in our head. Our problems are how we think about this.
Yeah, and it kind of reminds me of looking back about 4 weeks ago. The Economist did a good article on how European countries have tackled this a little more effectively and leveraging more of public-private partnerships. Glenn also touched base on it this morning, talking about, selling the bottom line on what the investment in this infrastructure means. And, they're juggling even thoughts and on, kind of rethinking how government bonds work as being a potential, investment piece for raising the capital to invest in this infrastructure stuff that's been done more progressively in other nations. So I would encourage you to look back to, I believe it was about mid-April's edition of The Economist, if you're interested in reading that article. Maybe try one more. Yes, sir.
Wasted and not being harnessed. That's the thing that you guys got to get moving. You got to get it. You've known about this for a long time. It's traditional. It's not new technology. It's proven. It's right in front of you. Monetize it. If you can't monetize it yourself, let the private sector help you.
Well, and as a follow-up, many plants do their ROI on biogas upgrades and won't do it because their energy is too cheap. And so, related to his previous question, as you get a cheaper electricity rate, it disincentivizes you to want to use that biogas.
Right. We are pursuing biogas, at Calumet and at Stickney. One of the problems that we have is being able to find a market where they would buy that much biogas from us for a long term. So. One of the issues that we came up at Calumet was being able to transport the amount of, we were trying to convert it into there was a big RFP out for Calumet for asking for different organizations to provide us with solutions for all the biogas that we're producing at Calumet. And,
Use the electricity on site.
Well, right, but there's also a cost for that. So, I mean, Kevin mentioned earlier about running a turbine, at the plant. I would like to, but his electricity, I think you said, is 5 to 12 cents on peak. Well, our electricity is 5 cents around the clock. So when you try to do a math on his turbine, it won't work for us. I mean, financially, it won't work for us. So I think you get into that dynamic of, we have engineers that are doing financial modeling, and they're saying, okay, it's still cheaper to buy, but then you also have the question of you're burning the gas. So we were trying to convert the gas for Calumet into liquid natural gas and see if we can transport it to somebody else.
That's actually more expensive.
And we were looking at that too, and there's also, so there's a cost and trying to balance it is what takes years and trying to plan it,
So I'm going to have to stop the discussion short. Unfortunately, I found it to be an exciting session. I hope you all did as well. I can assure you that Dave and the law school do charge by the minute like most lawyers, so I'm not going to run over too much longer. It's a lesson I've learned painfully in the past. So with that, I hope this collaboration spills over into the lunch break. Look forward to building off this in the afternoons, and just give a round of applause to our panelists. Thank you.
Yeah, it's not easy, is it?
Thank you, Matt and panelists. So we have arrived at the time for lunch. Today we're using the working lunch model. I can tell from the great questions that we've gotten and from all the talent we have in the room here that there's a lot of knowledge and interest that I want to harvest here. So what I would ask is that you move next door to the lunchroom where we have the tables set up, pick up a box lunch and have a seat, and then start talking about some of these issues with the folks at your table. So on each table, you'll find a set of 2 questions, a pad of paper, and a pen. Please elect a table scribe who can take down some of your discussions. And then about 30 minutes in, around 12 o'clock or shortly after, I'll bring us together as a group and ask for some of your feedback on the 2 questions. And I'll tell you what they are right now. The first is, why are policy solutions to food, energy, water nexus problems often conceptualized as a zero-sum game? In other words, there are winners and there are losers. what opportunities can we identify for mutual gain rather than zero-sum situations. And the second is simply to identify some important food, energy, water intersections in our region or in your organization's operational footprint. Who are the key stakeholders? What are the potential synergies that we should be exploring? So that's what I hope we can get out of our lunch discussion, get everyone a chance to be involved. So please do proceed next door, and we'll start our lunch. Thanks. Okay, I know we still have some folks coming back in from lunch, but I'd ask you to take your seats so we can get started so as to give the full time to our next speaker. They will, yes. Yeah, and Dave Marsh just asked, will these presentations be available afterwards? And the answer is yes. We are recording these, and they'll be archived soon in our online website. So I'd now like to introduce our next speaker, Dr. Tim Griffin, to tell us about agriculture's role in the food, energy, water nexus. Dr. Griffin is an associate professor at the Friedman School of Nutrition, Science, and Policy at Tufts University. At Friedman, he directs the interdisciplinary graduate program, Agriculture, Food, and the Environment, and teaches classes on U.S. agriculture and agricultural science and policy. His current research focuses on regional food systems and climate change impacts on agriculture, and he supervises doctoral students conducting research on topics ranging from precision agriculture to food access. Please welcome Tim Griffin.
Great. And thank you so much to David and others for the invitation to come and talk today. I'm going to talk about linking agriculture and water. And speaker's prerogative, you can always change the topic after you agree to come to another place. So I'm also going to talk about energy, and I put it in little font because I wasn't going to talk about it very much, but just because of some of the things I've heard already this morning, I may expand that a little bit. It is the coveted after lunch spot, so it will be, I wouldn't call it a data-free talk, but it's there's not a lot of data. I'm actually going to do a lot of this just pictorially. And one of my goals really was to kind of bring agriculture into the room. You know, I speak at a lot of different places, and many times everybody in the audience is already involved in agriculture. I've talked to a few of you today, and some of you are closely tied to agriculture in different ways, but I'm going to try to bring in, by way of example, some of the ways that we already know that agriculture and water and energy are linked in some way, and try to maybe highlight or flag some of the areas that I think are certainly for students and early career folks, areas where there is a tremendous need for innovation and kind of new thinking. In the U.S. and to some extent globally. So you could, you know, there's lumpers and splitters. So you could start to kind of bifurcate agriculture pretty quickly. And originally I thought, you know, we could bifurcate it and talk about animal agriculture, which of course relies on crop agriculture, and then you could talk about crop agriculture, and we can do that. But you can also look at kind of extensive systems. And they are extensive primarily in the way that they utilize land. And even though many people tend to think of things like beef production in the United States as being intensely concentrated in feedlots, most of that production system is actually extensive. It's based on grasslands and in the West, grazing lands, many of them publicly owned. So this is actually the start of my career back 35 years ago, I guess, in rangeland ecology in Nebraska and kind of the Intermountain West. And it was a really, looking only backwards now, I realized that it was the beginning of the point where I focused on interdisciplinary work and kind of an interdisciplinary viewpoint. And I've been extremely fortunate that I've been able to do it continuously since then through multiple careers. My position at Tufts is essentially my third career. So I've worked on this. I've worked with beef. I've on the animal side, certainly I've spent more time working with dairy than any other animal industry. I've been in New England for a long time, and their dairy is the primary animal industry. But I also have worked with much more intensive agriculture, so high value, intensive in terms of capital, labor, land use, and certainly the water side, and in some aspects, energy. So on the crop side, I've done way too many things to list, but one of the industries that illustrates this that I've worked a lot with, both in Michigan as a graduate student and subsequently in the Northeast, is the potato industry. Moderately irrigated, not to the extent that it is in other places like Idaho. So what I want to do is just bring some of that experience that I've had over the last decades, and then maybe also think a little bit about this aspect of interdisciplinary or transdisciplinary. I'm part of another NSF-funded effort at Tufts that's interdisciplinary graduate training program, the IGERT program, that focuses on water diplomacy. So it's very much the questions that we had around mutual gains versus zero-sum games is something that we think about a lot, and transboundary issues associated with water. So at Nexus, all you have to do is just type Nexus in Google and you get good definitions. Obviously, oh, that was not cool. The first one, this connection or series, that's kind of how we think about this. I particularly like the last one, though. The nexus of all this activity was the disco. Those of you of a certain age will remember that's true. So this is one way that we can define it. And then the food, energy, water nexus, I've seen it portrayed this way many, many times, kind of a classic Venn diagram where you have areas where water is independent of the other facets, and then areas where it overlaps one, and then, of course, the kind of sweet spot in the middle, which we think of as the food, energy, water nexus, and can we solve problems within that. And just putting together my thoughts for this, and actually constructing this, and starting to see where this our conceptualization of a nexus maybe is oversimplified. For example, you can have resource issues or concerns with water that essentially don't involve agriculture at all, but the fact of the matter is you can't have agriculture without water, period. So essentially the food part should be nested within water. That's maybe an editorial comment, even though I'm an agriculture person, not what I would call a water person. And so they do overlap to varying degrees, but some of the discussions I've had around food, energy, water nexus is that we need to place ourselves firmly right in the center of this, and I find that that's going to be exceedingly difficult to do. We need to figure out kind of where can we make progress even if it's not right in the center. As I said, much of my discussion today will be on the connections, the series of connections, if you will, or linkages between agriculture and maybe more broadly the food system and water, which is really one of the primary focus for today. So you can also simplify just things like the hydrological cycle, right? And a piece of this landscape is obviously occupied by agriculture on a global scale, particularly when we use land use as a metric, but even water use. Agriculture is overwhelmingly the giant footprint of our species on the planet. There's really nothing that compares to it. Some of that is intensive agriculture, extensive agriculture, the impacts of land use change, to the extent that it influences the entire hydrological cycle. So there's no question at all about the strength or the magnitude of the relationship between those two things. As the saying goes, the pain is in the details. It's like, do we understand, intentional outcomes versus unintentional outcomes, or maybe unanticipated outcomes? as we manipulate resources on the scale that we do with agriculture, because it is just very, very large. And I'll give a little bit of scale in just a minute. There is, and I'll come back to this with a little bit more formal framework in a few minutes. The water that we use to produce the food supply on the planet is really also divided, the use of water is divided into two streams, if you will. One is rain-fed agriculture, which is by far the largest, and it would include a huge expanse of grazing land around the world that is not suitable either from the soil standpoint or the water standpoint for arable agriculture, for tilled agriculture. But even a lot of the production of staple grains that are the caloric base for the food system around the world, with the exception of rice, which obviously is very intensive from a water standpoint, both here and, for example, in Asia. Much of the other grain production, wheat, corn, some of the oil seeds, is still predominantly rain-fed. But it's at a scale that influences many, many other parts of the system. So we have to think about that. And as we heard, I think in every session this morning, the changes to date and the future changes in climate and how they influence the pattern and intensity of rainfall is going to impact agriculture in every part of the world, and some areas may be more so than others. So we do have to think about this, and when we, my work with farmers over the years, thinking about conservation practices, both to hold soil in place, but also to make more efficient use of water, much of that work was making more efficient use of water that fell from the sky, rather than water that was extracted from groundwater or was diverted from surface sources or what have you. And then there is irrigation, which as a percent of agricultural land base is relatively small. It has an outsized influence on its contribution to the food supply. Because in many places, and we'll get a couple of examples of this in a minute, there essentially would be no contribution to the food supply if it weren't for irrigation. But that's not true everywhere. So this is center pivot irrigation, which widely used, particularly in the Great Plains. Nebraska is the biggest example of this. It's almost all center pivot irrigated now, some 10 million acres, something around there. This is an area where technology, the contribution of technology has really been already recognized over a period of decades. So there's a lot of discussion, at least in conversations that I've been in, that want to move from one end of the irrigation spectrum all the way to the other, and they want to do it all at once. For example, go into the Central Valley of California, and why are we doing flood irrigation when we could be doing buried tape drip? Well, there's a whole bunch of things in between those that are maybe more incremental gains in efficiencies. But, and then we have systems like this, millions of acres of irrigated corn, that the capital and labor requirements to do that with something other than a sprinkler are really overwhelming, given that you're producing a commodity that is then used in many, many, many other products. But the gain here has been a lot. I had a really interesting conversation about 3 weeks ago with a person that my wife and I have known for a long time around technologies like variable rate irrigation and kind of tied to that variable rate nitrogen applications. This is over the High Plains aquifer, the Ogallala aquifer. But my question to him was around profitability. And I said, do you think this makes you more money? And my gosh, he really wanted to say yes, but I could tell he wasn't going to, because we were in his shop and he was looking down at the floor, shaking his head, trying to figure out what he was going to say next. He was pretty certain that it didn't. In fact, it probably cost him. But the next thing he said was, it is an effective way to use less water and less nitrogen. So the benefit is not accrued to him if we use that technology. It's actually accrued to us, right? It's accrued to society. There's a policy implication to that, and that is who pays for the technology if it doesn't benefit the farmer or rancher who uses it. If there's an environmental benefit, this is the thinking behind all of the conservation programs that come out of USDA. You pay farmers because the benefits go to everybody. The farmer may benefit, but in many cases they may not. I've worked with a lot of farmers on a lot of conservation practices, and some of them are a net cost, at least in the short term. Energy use, certainly agriculture uses energy. The food system uses energy. There's lots of discussion around that energy use. For example, the energy associated with moving food long distances, that's actually a relatively small portion of the energy budget for the food system. I've used this even in my class. If you want to see the biggest single user of energy in the food system, just look in the mirror. In this country, it is household energy use associated with food. It is the hundreds of millions of refrigerators and stoves and things like that we have. Within agriculture, certainly, there has, I think it was mentioned this morning, huge gains in efficiency in energy use, fossil fuel use, especially within the agricultural sector. Partly associated with going to bigger equipment. This is very much a scale question. And then we've heard multiple examples of the ways that agriculture can contribute to energy. This one driven almost entirely by policy, but not agricultural policy, and it's the production of ethanol from corn. The EU went a somewhat different direction and produced biodiesel from soy and canola and palm and other things. And this just shows corn production and the location of ethanol refineries in this country. But we heard about many other potential contributions, things like anaerobic digesters and biogas. We're seeing more farms, and in some cases smaller farms than in the past, that are using renewable energy sources like geothermal. There's becoming some competition or tension between agriculture and other renewable sources like solar. So do you put, even in the Northeast where I live, you will now see solar arrays covering entire fields that were farmland. So there are, in some areas, tensions there, tensions with wind, those types of things. But certainly the potential, although most of that is currently implemented at the level of farm by farm by farm or ranch by ranch. It's not really a collective endeavor yet for renewable energy use. So what I want to do is just talk a little bit about some examples, and again, focusing, at least initially, primarily on the linkages between agriculture / the food system and water. And I want to talk about, to just bring to the table, if you will, some examples of the different kinds of interactions that exist. And we've heard a number of these already brought up this morning, but also kind of the magnitude of the interactions or linkages. And then different domains, and then geography. And I bring up the question of geography primarily because the solutions to complex problems are very much dependent. We can conceptualize them on a really big scale, but the application really changes depending on what the much more local scale is. So we don't, in the same way that we govern water differently in different parts of the United States, you could criticize the way that we do govern it in different parts of the United States. The fact is there's probably not a single system that's appropriate across all of the different geographies and hydrologies in this country. So there is a need to eventually get to what's the most appropriate way to solve these complex problems in this place, in a specific place. So we've seen some additional data on this already today. The the kind of mammoth role that agriculture has in using water. On the left is water withdrawals, and again, not all withdrawals are consumptive use of water, but agriculture, of the withdrawals, agriculture is also the biggest consumptive user. Industry second, and municipalities, cities and towns being smaller than that. So there's really no ignoring this. But again, the water that's being used depends on where you are, and I'll give you a couple of examples of that in just a minute. The water footprint, which also came up earlier today, kind of as a, both as a conceptual model for how we think about water, regardless of how it's being used, but also a developing database and data being much more high quality for some locales versus others. And this is from the work primarily by Hextra and others. Green water is rainwater, blue water is extracted or abstracted irrigation water, and gray water is essentially pollution. It's the amount of water needed to dilute pollutants to a tolerable point. And there are available data behind these. We've used some of it. I've had students use various pieces of it and trying to make it a higher resolution rather than lower. And this just gives you an example of this. So this is in cubic meters per capita by country. Some countries use a lot of water, tend not to be very efficient use of water, even in the home. That's true certainly of the United States. Some countries have very, very low water footprints, and partly that is because they have very low access to water. They are in arid places without access to irrigation, which is the constraint. So the linkage between food insecurity globally and water insecurity, either the quantity of water available or the quality of water available, those are pretty tightly linked. And that becomes something other than a technical issue. As someone said this morning, it's a moral issue also. Is if you view both food and water as human rights, then the fact that insecurity in both realms are linked is something that we need to be thinking about. And this comes up a lot in my classes even around food, as we could fix problems if we just charged more for food, if it was more expensive. True enough. But if you can't afford healthy food now, what happens if we implement policies that double the price of food? Or that increase the price of water used to grow food, which might be an appropriate tool, a market approach, if you will, but we do have to be thinking about what are the most vulnerable parts of populations that are going to be influenced by that. So you have to think through the policy. This is also from Hextra, just to give you an idea of the magnitude of the interaction or the footprint of agriculture on water. This is from their 2012 article, I think, and I love the title of this article, The Water Footprint of Humanity. I mean, that's a classic title. And the conclusion of it is that about 90% of that footprint is due in some way to food and agriculture. So it is very, very large. A lot of that is, in the upper left of that, is the use of rainwater to grow food. It is green water that falls as precipitation, and then on the hundreds of millions, low billions of acres that we use to grow food that uses that. And that, to be honest, that gets lost a little bit in translation as we generalize things. And the point came up this morning about the diversity of water footprints associated with different foods, which is absolutely true. But much of the way that that's portrayed doesn't distinguish between, is this rainwater, or irrigation water, or drinking water for animals, or all of those, or pollution, or whatever. The big impact is that plants grow out on the landscape and they use water that falls from the sky. And a little bit more nuance in those areas would probably be a good thing. We do think of water as an input, and I'm going to kind of move from the eastern U.S. to the western U.S. In the east, as was said this morning, and this would be true in Wisconsin also, we have periods of time where agricultural production is constrained because we don't have enough water, and then other times where it is constrained or harmed because we have too much. That would be true of kind of everything east of Omaha, basically. It's certainly the system that I've worked in for decades in the east. There is, those constraints become much more noticeable at kind of the classic delineation would be about the 100th meridian, which goes about through Kearney, Nebraska, a little further west than that, where you could still do extensive agriculture based on things like grazing livestock, but you're likely not going to be sustainable if you're doing arable agriculture. Things like growing dryland wheat in eastern Colorado, those types of things. And then you get to places like this, the Central Valley of California, right through the center of this, which would be, if it weren't for irrigation, would be completely brown here because it is reliant, not literally 100% of the water budget for agriculture is irrigation, but it's very, very high. And we heard a number of examples from California this morning about the use of both surface and groundwater in that area. This has a huge food security implication, right? That you may have all kinds of problems with the fact that they're irrigating this desert in the Central Valley. The other side of that coin is that either if we chose not to have that happen or the water were no longer available under different scenarios, they also produce 50 to 60% of all the fruits and vegetables and nuts grown in the United States, in California, in one state. Mostly in the Central Valley, but not exclusively. So there's a nice tight linkage for you around future availability of water. And, our diets then, we have several choices. We could redistribute production of those crops across the United States, or we could take the market approach and we could just buy them from wherever on the globe we choose to buy them. In this country, we could probably afford to do that. Many countries, that would absolutely not be the case. Those systems in the West, this is, collective infrastructure, large-scale storage coming from snowpack to reservoirs to big conveyances, all the way down to individual, irrigating this part of this field. Some of the larger conveyances obviously built through federal efforts. Smaller ones may be more local, but they may not. So there is water as an input that influences productivity. And productivity is important on the food side because that's the kind of baseline for overall food security. Are we producing enough of different kinds of products? You also have agriculture as a driver. This is primarily, I'm thinking of this in the environmental realm, about this kind of a classic picture of a field with no residue on it. We should not be amazed that when it rains really hard, it runs sideways. Down at the bottom, there's actually a barbed wire fence there, but it's completely silted over. So this problem needs to be solved at the level of this field, right? So if you go to here, the outflow of the Mississippi below New Orleans, can't miss it. That's the collective output of, let's say, 90 million acres of cropland. So you cannot fix this problem here. You have to fix it kind of farm by farm, ranch by ranch, and for this watershed, it goes all the way up into Montana from New Orleans. So we can think about it and conceptualize it as, wow, the Mississippi watershed is really big. It's 43% of the lower 48 states. But to fix the problem, it's like 10 acres at a time spread throughout that. There's really no other solution other than you're solving it at the source of the problem, which is here. It is not here. So we need to keep that in mind. The other side, in agriculture, gets a lot of critique for doing things like the previous slide, right? Having fields that don't have any cover in an area that gets heavy rainfall. There's a lot less time spoken about or even thinking about either the current benefits or the future benefits that agriculture could provide in this regard. And there has been innovation in those areas. For example, the work that the city of New York has done up around their primary water source, which is in the Catskills. They have gone in and basically worked farm by farm by farm to implement practices there to protect it, because the alternative was to clean the water before it got to New York, right? Much, much cheaper to solve the problem at the source rather than right before it goes into the municipal supply. So it's still billions of dollars, but it's not tens of billions. So there are solutions out there. We've heard about climate impacts on agriculture that are kind of mediated through water, or a combination of water and increased temperatures during the growing season. This map was actually 2011, when there was significant flooding down through the Missouri basin. And then someone mentioned this morning the drought of 2012. The implications of climate change are that these events will become more frequent, and for droughts, deeper. So they may be longer, or they may be more severe. In the Northeast, the one that we're really thinking about, because we can already see a pretty dramatic increase in high-intensity precipitation events, particularly those that occur outside of the growing season. So when our agricultural landscape is not fully covered with green growing material, in many cases it's bare, and getting rainfall events in November that might be 3 inches or 5 inches, or in April, or in some cases even in Maine and New Hampshire in February. So those, again, I like the discussion of it in one of the talks this morning about it's not clear that we have an overall increase in drought. We do need to go down to specific geographies to think about what the implications of that are. And again, it influences the food supply. There is the governance of water, which could be political and regulatory governance, which is why I show this. If you're familiar with the natural resource districts of Nebraska, established in the 1970s, right when irrigation was really ramping up in Nebraska, and Nebraska is blessed with the northern part of the High Plains Aquifer, which has a pretty sufficient recharge. But they also have a very innovative system to govern that, where it's down to the level of these individual NRDs, and they have really powers, if you will, that are unheard of anywhere else. So they have the power of taxation to try to fix problems. They can implement control measures that farmers have to adopt. So things like metering of wells. They haven't done it yet, but there are a few places in the kind of lower left, the big little blue and the upper big blue, where they're getting close to doing allocations of water, meaning that you can only extract so much over a 3-year period, which is, if you go across the border into Kansas to the south, that's something that they have not done, and the situation in western Kansas is much more dire than it is in Nebraska. So one of my doctoral students is actually working on 4 of these NRDs, which are now working together, but they're focused on water quality. They're focused on nitrate contamination up in the northeast part of Nebraska. So there are lots of different models. You go to the west, it's prior appropriation. There are, kind of the law of the river along the Colorado River. have not been very many innovations in this regard. This was an early innovation, and they allow the system to change over time, which I think is probably a critical piece, because certainly irrigated agriculture has changed over time in Nebraska. Even at smaller scales, this would go all the way down to smallholder farms in Asia, Central Asia, Sub-Saharan Africa, where agriculture is at a big enough presence on the landscape that even smallholders, when we do things like, can I build small catchments to catch rainwater during heavy events and then use it for irrigation, is influencing the hydrology for the entire basin. So you get you can't go and say to one smallholder farm, you shouldn't do this. The issue is that there's tens of thousands or hundreds of thousands of farms that might do it. So those are very, very complex problems. And again, you're dealing with a population that is mostly poor and mostly farmers. So a very, very different set of issues than we see in most parts of this country. The trade-off between benefits, this is kind of one of the classic food, energy, water nexus, which is construction of dams for both hydroelectric power and to hold water for irrigation. But those two needs may not be coincident in time. There's plenty of examples of that, for example, in Central Asia, in the Aral Sea region, where there's significant dam building, but water releases are timed for energy, but they're not timed for irrigation. Those types of things. So you could focus on these at any number of scales that you choose to focus on them. This certainly is a big story in the western part of this country, and this has influenced competition in agriculture in this country. So I said I worked a lot with the potato industry, but it was the potato industry in the East, and they could only dream of the electric rates and the availability of water that they have in places like eastern Washington and Idaho to grow potatoes. They also have sunshine like 318 days a year, so that also makes a difference. But so there are advantages to even segments of agriculture as we've developed energy resources in the western U.S. There are many, many stakeholder perspectives. We heard some of that. We talked about that actually at our table at lunch a little bit. And those perspectives could be agricultural, they could be environmental, they could be social. We had a symposium at Tufts last week, or on Saturday, I guess, with our water diplomacy students, one of whom is very interested in who advocates for things like salmon and ducks as stakeholders. So obviously they're not literally going to bring the duck to the table, but they're kind of proxy stakeholders. And when we're talking about environmental flows of water, this is a significant issue. And it's in some places, for example, in the Northwest, the Pacific Northwest, that dynamic has changed over the last 25 years. In other places, it definitely has not. It's still, from the very first day, it's very, very confrontational, and we have to think about how we get past that. On the food security side, I made the point before twice. I'll make it again. Even in I've done some work in policy arenas kind of at different scales, regional, sub-state, state, the Northeast. And it's surprising how often the most vulnerable populations are not represented at all when we're trying to deal with complex issues in the food system. It's like the starting point is, let's get everybody that can already afford a healthy diet, and we'll get together and talk. And there's just no representation there. And for all of these issues, if we're thinking about this as how do we bring together the right aggregation of interest going forward, we have to pay more attention to it. And it's, it may be an economic, we may be thinking about economic or market-based tools, and we have to think about how are the costs for that distributed across different segments of the population and different interests across this country. So I want to just return to this for just a minute. I said that if I had any skill at all graphically, I would reconfigure this and then, copyright it or trademark it or something, but I don't. One of my interests / concerns is that as we think about this, and it's becoming very much a catchphrase, the Food, Energy, Water Nexus, and NSF now funds a program specifically in its Infuse. It includes this nexus. On the research side, so what we've been talking and hearing about a lot today is very much kind of practitioner-oriented, if you will. Like, how do we solve very real problems that are in our community? Community could be the Milwaukee area, it could be the entire United States, whatever. From the research side, we've yet to catch up. So I have a couple of doctoral students that did a formal systematic review to try to find research that was at, ideally at the nexus, the three-way nexus in the middle, and that saw itself as operating at that nexus. And that research base is tiny, tiny, tiny. It's a small handful of articles over the last 10 years. So as a scientist and as an educator, one of the things I'm wrestling with is how do we move forward that part of it? I mean, research sometimes takes a long time to help solve problems, but it does need to be done, but it needs to be well constructed. And a lot of what we'll see instead is, there's plenty of research out there that connects water and agriculture, but it tends to be very, very specific. So, for example, I did some work 10 or 12 years ago on behalf of potato farmers, just looking at different strategies to try to cover soil so that we could reduce soil erosion. Okay? That's a water issue and a soils issue. Very straightforward, clearly defined objectives that would actually fit at that intersection, right, of water and food or water and agriculture. I would not classify that article as, the cutting edge of the nexus between food and agriculture. It's very much about how do we use a resource to accomplish a certain outcome. To me, anyway, that doesn't include, it's not nearly as comprehensive as the nexus. This is the other bridge that we must cross. And again, editorial comment, because it's my second to last slide. I get to editorialize. And that is on the research side, but this could apply even to thinking about what different categories of stakeholders do we bring to the table to try to solve problems, is the continuing divide between the natural sciences, maybe the natural sciences and engineering, versus the social sciences, economics, anthropology, all of those kinds of things. What we've done within our water diplomacy program is brought students together that actually wanted to cross that divide within their dissertation work. So they might be primarily working on, wetland birds, which is a natural science problem, but they're also looking at is the way that wetland development is regulated, which is a policy problem. How does that influence the outcomes there? So for students or early career folks, you don't have to have a room full of people that can all think that way, but I'm absolutely convinced that you cannot solve those complex problems if you don't have at least some people that can view or think across these divides. Part of it's like translation. Do you actually understand what the other interests are talking about? So this is the area that I've been very lucky myself, because I've been able to work across a whole bunch of interests. But I don't see us solving these really complex issues with at least some people that are comfortable in that position, if you will. Okay, I'm going to stop there. I'd be happy to take questions for however long David lets me. Thank you.
Thank you very much for that presentation. Sure. I really enjoyed that. One comment and then one question. You mentioned the New York City water example very briefly. I'm sure you could spend a whole lecture just on that one. So in that situation, I think it was good for New York City, right? Yep. I'm not so sure it was good for everybody else. You know, you read some literature about how perhaps they took a fairly draconian approach to acquiring or of not acquiring it with the farmers, right? So maybe the farmers didn't necessarily win there. The other side of that is if you look at the rest of the states in the Delaware River Basin, now they are very, subject to the way that New York City operates.
Absolutely.
Reservoirs.
Not a perfect situation.
Far
Absolutely.
From perfect, right?
Absolutely.
Far from perfect. So just an example, right, of approaching this and creating more problems, more challenges. I guess my question then is going to be if you think, and this goes back to the delta picture you showed, and then saying we need to do this at the farm scale, which I completely agree, thinking about management. What management aspects would you maybe prescribe as some of the better ones? And I'm going to preface this by saying we look at Iowa, we look at drain tile that's been put in. Maybe that's good in a lot of ways. Then we look at the flood in Cedar Rapids and Iowa City, which I think most would say was probably caused by those drain tiles, right? Again, a propagation of these challenges.
Yeah. I mean, there is, and we talked about this a little bit at our table at lunch. Is also now you have like this so tile drainage is an example. It's also in northern Ohio and into Lake Erie, where 25 years ago, if somebody, when I was working with farmers and they wanted to talk about phosphorus leaching, my response as a soil scientist would have been phosphorus doesn't leach. Well, that's clearly not the case because those tile drains are direct pipelines now, right, of phosphorus. We always think of it in terms of nitrogen, but the issue is now you have, whether it's in northern Iowa or northern Ohio or other places around the country, and you have those millions of acres of land that are tile drained, it is a very difficult proposition to figure out how do we maintain productive agriculture there with those tile drains, and they're still there, and then fix the environmental problem, partly because of the legacy effect that was discussed this morning, that the same would be true of the flow of nitrogen through the center of the Corn Belt that ends up in the Mississippi, is that we actually might be fixing it and we don't know, right? Because the return time is just so long. So those areas where the system is really locked into a particular production, not a paradigm, but it has a particular infrastructure, and then all of the inputs and the output markets are all centered around that infrastructure. For a lot of the food system problems, that's the really, really hard one, is how do you, 50 years from now, that system's going to have to look different. And can we visualize what it might look like? And if we can, how do we get there? And how do we treat interests equitably in getting there? In terms of individual production practices, I mean, for some things, and I think I mentioned soil erosion, so sediment loss, irrespective of whether we're talking about N or P or whatever, to hold soil in place is really not that complicated. You need to keep the soil covered, and it's better if it's covered with things that are live than things that are dead, right? Having said that, I was doing research on cover crops in Michigan in 1987. And now cover crops are like the cool thing that, just came out. It's the new model, right? It just came out yesterday. So, sometimes it takes a while to catch up, but for some things, the solutions are very, very apparent, like erosion. For others, like flow of N, maybe flow of pesticides, much, much more complex. And do you really need a system that looks very different? Or can you implement practices on a field that will fix the problem? I'm a little skeptical of that. I think in some places it's actually going to end up, it's going to be a different system. It has to be. Yes. Yeah.
This builds off the last question as well. You mentioned that the change needs to happen kind of at the farm scale, and you talked about some examples.
Yep.
I'm wondering what you think sort of needs to change, what policy changes need to happen to facilitate that? Like, is it additional, expanding grant programs like you mentioned, funding county conservation programs or extension?
Well, I would vote for all of those, right? because it will take more resources. But I think also, and I've spent a lot of time talking to different interests, but also among my students with this, that, and we talked about this a little bit over lunch, and that is, one, if there's a developing problem, rather than there is a set in stone problem, which was kind of the situation we were describing, right? If there's a developing problem, the places where I've seen it be more successful is that if not every single interest, but maybe what we think of as competing interests actually come to the table and try to solve it together. And I'll give you a concrete example of this. When I moved to Maine in the early 90s, in an area that's very mixed between dairy farms, small to large, and potato farms, large and small, and a beautiful lake that bloomed every year. And the agricultural community said, you know what, we know it's not all us because there's all those camps from the 1940s, 8 feet from the lake, right, and they have a septic system. We know some of it's coming there. But they said, we are going to take responsibility for the agriculture side of that. So they worked with soil and water conservation and what at that time was SCS and extension and all of that, and started, the very conventional farms, if you will. And they implemented this giant program to figure out, like, how do you cover crop in silage corn that you know is going to come off in September and leave like this, right? So they did it themselves, and it worked. And I've had I check in with that group occasionally. So this is 25 years ago. Now they don't have any funds coming in, so they're not using EQIP funds from NRCS. Most of those farms are still doing it. It's a net cost to them, probably, but not a great one. But they took leadership. So the USDA types of programs, USDA is very, very reluctant to target individual farming or ranching operations and say, we think you have a problem. They are piloting some things like the Regional Conservation Partnership Program, where it is more locally based. And it actually would be, for example, groups of an agricultural interest in a particular area that will actually go out and help. They will go identify where they think there are problems, and they will go talk to those people and say, here's 5 programs you can participate in, and we will find the resources to help you do that. But it's a very different thing if it's another farmer versus if it's somebody from a federal or a state agency saying, what are you doing, right? So there's some developing positive things I see from USDA. I'm a former USDA employee. I think I can say this. They tend to move fairly slowly, especially on things like that. But they're trying some things that I think actually have a lot of promise, and it gets them out of being the agency that says, why are you doing that? Because USDA is uncomfortable doing that. That's why. So.
We've reached the end of Dr. Griffin's time. However, our ethics speaker has been slightly delayed coming over from her office. So I'm going to, if you don't mind.
Oh, no, heavens no. No.
Try to go track her down.
Yeah, Jared.
Yeah, it was a great talk. Thank you. Really enjoyed it. It was a good after lunch talk. So I think, we've created these problems that take a long time to solve, but we also we develop policy that immediately creates a problem that's going to take a long time to solve. And I'll point to the biofuels, the ethanol standard, as a disaster. In my view, we don't have second generation food feedstock. Nutrient loadings have increased noticeably. There's more land, land's been taken out of seep into production. Food prices have increased generally, although corn prices are down a bit.
Yep.
And so, we got to quit, stubbing our toe and creating these problems that are now going to take a long time to solve.
Yep. Yeah, and that particular one, the renewable fuel standard, which started in 05, 07, somewhere right around there. On the surface of it, it's a very, all you have to do is look at the graph from EPA, right? It says we need to be at this many billion gallons year by year until 2017. So that's pretty straightforward. But you think of how that kind of reverberates literally through the landscape. And, it did force or drive changes on the landscape scale. Not everywhere. In Iowa, for example, we saw a shift away from soy and into corn, but it was all corn and soy to start with, essentially. But like expansion of the Corn Belt to the west into South Dakota and parts of Nebraska that were not being used for corn. And it was, millions of acres, maybe 5 million. But it's a remarkable example because the policy was like crystal clear. We're going to do A, and the outcome is going to be B, which is billions of gallons of liquid ethanol, without a thought of how that might influence everything else. And it's been, and then this kind of, the fact that we're not even going really back and revisiting whether we should continue to do it at that level. It could be smaller, it could be bigger, whatever. It's just, no, we're still following the graph that says we need to be at this many billions of gallons. And it's, the extent to which it's stifled innovation to try to develop other types of biofuels. I am not an expert in any way, but I would wonder how big that constriction of that innovation is. So, yeah, it's a great example. Any others? Going once? Yeah. Thanks. Yes. Yep. Yep. Yeah. That's a great question because it's something that we've thought about, not quite as much. I mean, I like your specific example. It's about phosphorus, where we're now getting places that are really, really concentrated because we're moving feed into those areas. The Delmarva would be one, but there would be plenty of others. But this idea of how do different scales coordinate is something that, again, I have like no business actually doing work in that area, but I'm really curious about it. Okay, so at least I can raise the issues, right? And I get this from the food system side where people say, we should just make sure that all farms are small and they're all local. Well, that's not possible. And I'm more interested in, if you want to stimulate, for example, small farms, then what's their relationship to big farms? Because big farms are still going to exist. But your question of phosphorus, that's like moving nutrients on a continental scale, right? Which is, you're talking about, 50-year time frames. And we've seen how we got to the point where it's that concentrated, and it's by moving nutrients on that scale. The question that begs to be asked is, how do you move nutrients away, right? How do you, in the area that they're concentrated, the solution locally is to reduce the concentration of nutrients. So how do you do that? Yes. Absolutely. And again, that kind of goes back to the question of practice, right? So that's where I started my work back decades ago, was very much about the picture I showed with the erosion. Okay, how do you fix that? It's not that complicated. One, you don't have to plow it, or you could plow it less, and secondly, you could keep stuff growing on it, and that keeps at least the soil and the phosphorus in place. If it has a cover crop, you may be able to keep nitrogen at the top of the profile. It's like there's 10 practices that if we could just implement them on 100 million or 150 million acres of land in this country, would make a huge difference. But cover crops, it's like 4% of cropland. So yeah. I mean, the issue has been, talking to farmers about this, is that particularly early on in their adoption period, it's a net capital cost to them, and it's a labor cost, and they have to learn it, right? So, well, although currently we don't subsidize corn ethanol at all, right? Those subsidies were gone. So we did. We did. But the issue with farmers is, so you could establish a contract with USDA to do cover crops, and they'll usually go 2 to 3 years. The benefit in terms of like reducing erosion, it's like that, right? You keep the soil covered, you reduce erosion. The issue from the farmer standpoint is the long-term benefits of having a growing cover crop there are longer than 3 years. They're thinking, you know, they really start to see it maybe at year 5 or 6. So it was my earlier example where we're accruing the environmental benefit, but they are paying the cost if we're not providing that incentive, which is a subsidy.
Tim, I'm gonna have to...
In a good way. Okay? All right.
Yeah,
very good.
Great discussion, and we will have some more time to talk about this during our second breakout. And
perfect.
Please join me in thanking Tim Griffin. Thanks for pressing that. Okay, thanks again, Tim, for that excellent presentation. When our organizing committee met to discuss the outline for this conference, several of us noted something that's often missing from events like this, and that is specifically a discussion of ethics. And we wanted to make sure that we didn't fall victim to that same thing. We wanted to be fully inclusive of those considerations and to stimulate really a reflective and responsible approach to research and operations in the Nexus. So we're very fortunate to be joined by Dr. Jamie Schaefer of the Marquette Department of Theology. Dr. Schaefer is Associate Professor of Systematic Theology and Ethics at Marquette, where she focuses on relating theology, the natural sciences, and technology, and she also directs the interdisciplinary minor in environmental ethics. Prior to entering academia, she served as in various environmental and energy policy positions by appointment of local, state, national, and binational governments. And I have to say, I'm very grateful to all of our speakers, but Jamie, I think, deserves special commendation because I have a knack for scheduling these things, but today happens to be the grading deadline for Marquette University. And so I've fallen victim to that problem, but Jamie in particular had any number of students who just took their final, which was an essay exam, on Friday afternoon, and the grades were due at noon today. So she's been working hard to get those done and still has been willing to join us to share her expertise with us. So thank you, Jamie, and please welcome Dr. Schaefer.
So, David, this is a pointer? Thank you. Well, good afternoon. And this is a departure from what I've been doing almost nonstop since Friday at 5:30. So I'm really happy to join you, and I've been excited when I've heard about what David was planning for this workshop. It's certainly an important topic. And ever since he asked me, I went online to see what else has been done on the topic, and I'm absolutely amazed at the number of conferences that have been held on this, working through the interplay of so many of the actors that are involved in addressing issues at the nexus of food, energy, and water. So, I commend you for carrying this on, and especially for bringing this to Marquette University with the focus on innovation at the nexus. This is the first conference that I'm aware of that I could find that was focused on innovation at the Nexus. I might be wrong, but this is the first that I've seen. So it's really wonderful that you've initiated that here at Marquette University. So, and I think what you're doing is especially important. And for me, to be involved in something like this is a bit of a challenge because I hadn't thought about innovation at the nexus of food, energy, and water, but I had to. And so what you're going to hear from me will be some of my initial thoughts drawing upon some of the sources that have especially impressed me over time. And among the sources that I have drawn upon that have been significant for me are the sources probing what's called integral theory and integral ecology. Some of you may know some of the work of Ken Wilber and others on these topics. Also, I've been very much influenced over time by Aldo Leopold and his land ethic, and I will be referring to that as well in my presentation. And of course, I cannot help but be influenced in one way or another deeply by Ignatian spirituality, and then in particular by Bernard Lonergan, the theologian, systematic theologian, who has just recently, within the past year and a half, especially profoundly affected me in the way in which I think about bias, and I'll be getting to that shortly. And of course, I draw upon my own experiences teaching the capstone seminar for the environmental ethics minor, where students are charged with identifying one problem and addressing it from multidisciplinary perspectives, bringing all of these different ways of knowing, their knowledge and skills from these different ways of knowing, to address that problem from a faith-based ethical perspective. And they just finished a really exciting project that we are hoping the Archdiocese of Milwaukee will put on their website, and it's called Flipping the Default, from fossil fuels to renewable energy and efficient energy sources in the state of Wisconsin. And it was an exciting project, as usual, an exhausting project, but nevertheless, it's done and it's been tweaked, and we're just waiting for a vote by the different priests in the Archdiocese as to whether or not they will put that toolkit for flipping the default on their webpage. So, as I've looked over from my own experiences and the effects on me, as I've thought about this project in which you are engaged, I thought that my best approach to this, and I thought of different possibilities, but I thought my best approach to this would be looking at this topic there. From these three perspectives, looking at the stakeholders, asking the question, who are the stakeholders? And you might anticipate I'll have a more expansive view of stakeholders. Looking at some of the challenges I'm assuming that you are facing as you're thinking about innovation at the nexus of food, water, and energy. And then I'm going to come up with some of my own guidelines for ethical guidelines for innovators, and I'm going to be closing with an invitation to you to help me have a more full list of what these guidelines might be, what I might have missed. And that I think will enable us to have some kind of an interactive conversation. So, who are the stakeholders? Well, let's define that term, and I've come up with a very broad definition of the term, looking at different sources. And I've come up with the idea of, of the stakeholder as an organization or system, thinking broadly, in which all members or participants, thinking broadly, have an interest in its success. So that's the basic definition that I'm going to be using. And we know, you know, and you've been discussing, at least I've looked at the topics that you've been discussing up to this point, and you know what those connections are between food, energy, and water, and what they mean then for innovations, and the kind of innovation in which you will be creatively engaged. And so, of course, we know some of them are producers and transporters of food, producers and distributors of energy, processors and distributors of water, and on and on and on. You probably have a much longer list than I've tried to categorize up here. But also then, we have to consider the consumers, correct? The consumers of water, food, and energy today. And then we have to think about the people who are affected directly and indirectly by the production, distribution, and consumption of food and energy, the disposition of food and energy residuals and wastes, and the processing, distribution, and consumption of water, that valuable source, that good of earth with which none of us organic beings can live without. But also, in addition to current people, we have to think about the next generation and beyond of people who are affected by the production, distribution, and current consumption of food, energy, and water, and the disposition of residuals. So, now I ask, can we limit the stakeholders to people? Not only in the present, but in the future? I think not. I think that we have to think more expansively about who the stakeholders are, and I would insist that they would include other species who are affected. They are stakeholders. They have an interest in this system remaining robust. And their habitats, of course. We've been encroaching on their habitats for a long time. We've been accelerating the rate of species extinction for a long time, much because we have so destroyed or degraded their habitats. But then I would also insist that water is a stakeholder, that land is a stakeholder, and that the air is a stakeholder. So I think when you think about innovation and the interconnection of all species, air, land, water, you have to think about them as stakeholders. They have an investment. They don't conceptualize it as such, but they instinctually have an investment in how we are relating to them and how you are relating to them and thinking creatively about how you're going to propose and develop and implement innovations at the nexus of the three. Well, then we have to go further and talk about ecological systems, like the three rivers that converge in the Milwaukee area, Lake Michigan, the Great Lakes Basin ecosystem. And yes, expansively, the biosphere of our planet. They are stakeholders. And there's a whole body of literature in environmental ethics recognizing this. So, given my expansive view of stakeholders, what are some of the challenges to your actually discerning the kind of innovations that you're going to be developing and proposing and implementing at the nexus of food, water, and energy? Well, no-brainer, thinking expansively, thinking beyond human beings, thinking about our interconnections. And this is also a challenge, I think, thinking expansively for some, to actually recognize and respect and welcome and work with people from various different perspectives, especially specialized, people who are specialized in different fields, who have something to say, something to bring to the table when you're thinking about innovations at the nexus of food, water, and energy. Now, this might not, sound phenomenal or profound to you, but quite frankly, in my work at Marquette University and in my work in the various fields in which I've worked at different levels of government, one of the things that you encounter is a sense of bias, a bias for one's own discipline, a bias for one's own discipline as the primary way to address something. Now, when you're innovating at the nexus of food, energy, and water, you have to dispel your biases. You have to be open to other ways of thinking. You have to welcome the insight of other disciplines, the knowledge and skills that each discipline can bring, each specialization that can bring to the table. You simply cannot silo your particular perspective. You must open to others, and you must be ready to respect them and recognize that you need all of the knowledge and skills of the various ways of knowing, about the nexus of food, water, and energy in order to produce some kind of innovative technologies that might facilitate what I would call the flourishing of Earth, the flourishing of our planet. So, thinking expansively, welcoming others, welcoming their disciplines, welcoming their ways of knowing, welcoming their knowledge and their skills, that's all going to be highly important for any kind of innovation that you're going to be addressing. The second challenge, as I see it, is addressing the nexus inclusively. And by inclusively, this is where integral theory and integral ecology becomes very important, because there is no way that you're going to be able to separate out water, food, or energy. We know that. I'm sure that's been a topic that you've thought about a lot longer than I have, at least, in preparing for today. Food needs land and water for growing, and energy for producing, transporting, and disposing of food waste. Energy needs water for transporting foods and generating electricity. Energy needs biomass for liquid fuels, a renewable source of energy. Water needs energy for distributing to customers, for processing and distributing to customers. But we have these problems of the inequitable accessibility to food. And we have a problem with the diminishing and inequitably accessible potable water. And then, of course, we have the ongoing problem of emissions of non-renewable fossil fuels for transporting food, for generating electricity that facilitates the functioning of these processes. And we know that the emissions of fossil fuels continue to threaten a life-flourishing planet. We have lingering questions about water. We need to be optimizing water use in agriculture for crops and for dairy farms, especially in Wisconsin and the Midwest. We certainly have to work with water and the goods of water for sustaining wetland fisheries. And then, of course, we need to be developing energy-efficient water treatment technologies in all sectors of the economy. So these are just some problems that I've been able to identify, and you know that there are many more. So, lingering questions that pertain to fossil fuel use include minimizing the transportation of food products, encouraging use of locally grown foods, and carefully considering the effects of fossil fuels on water, on Lake Michigan, on the Great Lakes, and the oceans. Tremendous amount of concern now on the effect of emissions of fossil fuels in the oceans. And of course, we know that there are mounting pressures as populations grow and the demands for water, food, and energy increase. And all of this is so interrelated and interconnected that there are no easy solutions. And certainly, they challenge your ingenuity. They challenge your creativity. And this is where I have especially found that integral theory and integral ecology provide the kind of conceptual basis through which to start addressing some of these issues. It's one model that's capable of organizing all and bringing an inclusive approach to all of these issues, and hopefully being able to stimulate the outcome of innovations that are going to minimize or even mitigate some of the problems that persist. So that's another challenge, I think, to your work. Then the third challenge that I would propose is one of recognizing and considering the vulnerable. And again, the vulnerable for me, from my perspective, is going to be expansive. So we're talking here about people who are immediately affected by these issues and will be affected by any innovations that you propose. We're talking here about people in the future who are affected by the innovations. And of course, how you're able to minimize some of the adverse effects that have already occurred. when they've not been approached in an integral way that they need to be approached. Then, of course, we have other vulnerables, other species, abiota, the water, air, and land, ecological systems, and the biosphere. And here, I think, we are challenged. We're challenged in our thinking about other species and systems as strictly resources, as strictly ours to use, and in some cases, unfortunately, to use up. And here I think Aldo Leopold, the naturalist, used to teach at UW-Madison, and the proponent, developer and proponent of the land ethic, in which Leopold proposed that we think about ourselves, we human beings, think about ourselves as citizens of the biotic community, functioning cooperatively with other biota and abiota for our mutual flourishing. That's a hard one to wrap your mind around because we often tend to be highly anthropocentric and viewing other species and systems, the abiota that they constitute, as for our use. We think of them as instruments. We think of them as resources. We have to dispel that. We have to now think of them as among the vulnerable. Another person who helps a great deal about this, and from a theological, philosophical perspective, is Thomas Aquinas, who thought about human beings as rational cooperators among other cooperators, creatures, who work together for the mutual flourishing of the creation. And that's back in the 13th century, and it's very consonant with what Aldo Leopold is saying to us in the 20th century. Each acting according to their own abilities, but cooperating for their mutual good. Another person, I think, who's very helpful to draw upon and should be expected at Marquette University is Ignatius of Loyola, who understood the whole world, the creation, as a gift from God. And we, as receivers of that gift, who respond by serving. So we can conjure up an idea of conserving in a religious response. And there are many world religions who have wonderful ideas that are in sync with this type of spirituality. Then, of course, another person who's very helpful when we think about the vulnerable and who are the vulnerable, no less than Pope Francis, who in his epochal encyclical, Laudato Si, on Care for Our Common Home, issued in 2015, where he underscored valuing all people, species, and ecological systems intrinsically, for themselves, of themselves. He is the first pope to ever write a document to include these key valuing terms, philosophical terms of intrinsic valuing and instrumental valuing. He's very heavy on this notion of intrinsic valuing. They are species, ecological systems, the biosphere, Mother Earth for Pope Francis, who are among the vulnerable. And that presents a challenge for us to think about the vulnerable as other than human beings. But we are all connected. So that's a challenge, I think. The other challenge is assuring the representation of the voiceless. All right, now, these are other species and systems who do not have audible voices using the kind of language that we're familiar with. They have their own languages. But the voiceless would be other species and systems, biosphere of Earth, also the vulnerable and poor people who we know are most affected by the inaccessibility to potable water and to the other goods of Earth that facilitate their flourishing. And then, of course, the other voiceless would be future generations. So a challenge to you in your innovating would be to make sure that these interests of these stakeholders are represented in your deliberations. Then the inevitable challenge will be collaborating. And this then is going to stem from, first of all, being open to the knowledge and skills of other disciplines and valuing them and wanting to work with them and giving everybody equal time to present their particular perspective, what they can contribute to proposing some kind of innovation at the Nexus that's going to be successful. And successful, for the actual outcome, ultimately the outcome of the flourishing of our planet and mitigating some of the problems that we have been causing by our inappropriate and non-reflective decisions that have been made and continue to be made. So these are the challenges, at least, that I've been able to identify, and maybe you have already thought about more, and we can talk about that later. But right now, I'm going to get into the third part of what I've been playing with over the past few weeks, since David gave me this assignment. And that is, I'm going to be drawing upon Bernard Lonergan's systematic theologian, the late Bernard Lonergan, and his mantra, which is, be intelligent, be reasonable, and be responsible. We have a wonderful professor at Marquette University in my department, Bob Doran, who is the main interpreter of Bernard Lonergan. And I had the privilege of spending 2 years in a seminar session with some very bright graduate students who were Lonegarians. And I've learned a great deal from them and from Father Doran. And I've been especially impressed with his mantra, and I'm trying to put that to work today with you. Be intelligent, be reasonable, be responsible. And these will be the guidelines I'm thinking for innovators at the Food, Water, Energy Nexus. So, be intelligent. Oh, collectively, by the way, because you're going to be working together from different perspectives in addressing innovations at the nexus of food, water, and energy. So, first, be open to knowing and considering all possible aspects of the nexus, breaking down your biases, welcoming, not being siloed in your own discipline, your own specialization. Second, be imaginative. And my guess is there's no shortage of imagination among you in this room, or you wouldn't be here. Right? Be imaginative. Third, identify and include all stakeholders in your deliberations. And if you don't have representatives automatically, then identify representatives who can take their position and plead for consideration of their perspectives. And that, of course, includes future generations. It includes other species and systems as well. Identify the direct and indirect effects of potential innovations in the present. And that is going to take a great deal of discovery and thought on all of your parts. Because you're going to have to think carefully and again, expansively. I keep coming back to this expansive thinking because the challenge you have before you is just so interconnecting with so many different aspects that you have to continue to think expansively and think, especially in this case, of what the direct effects are of the innovation that you're proposing and then what the indirect effects may be in the present, and then the same way into the future, having some foresight, looking into the future, and what the effects might be of your proposed innovations. Identify the unknowns and the risks as best you can. And again, this is a case of thinking expansively and creatively and imaginatively. And of course, you will want to identify ways to minimize direct and indirect effects. So yeah, innovators should be intelligent individually and collectively, but especially in your case, it should have to be collectively. So Lonergan's second part of his mantra, be intelligent, be reasonable, be responsible. Yes, innovators should be reasonable. You should develop a discernment process in which all stakeholders can engage, either directly or by representation. So develop a discernment process, your step-by-step discernment process. Secondly, assure the representation of all who are affected now and in the future. It's only reasonable, or you're not going to come up with the kind of solution that's going to facilitate addressing some of the issues that you will be addressing. Third, discern the most effective and ecologically compatible innovations. Think, what is ecologically compatible? What is compatible that you can do at this nexus that will facilitate the flourishing of ecological systems, of species habitats, of the biosphere? Think big. Think big. Have that ultimate goal for yourselves. And that's only reasonable to want to take that step. Devise a process for monitoring, reporting, and evaluating outcomes of innovations. And that should be built into your whole process as a demonstration of being reasonable. And then I would say, adjust the innovation where necessary to minimize unanticipated risks, or maybe suspected risks, but really lots of uncertainty there, to people, other species, and systems of Earth. So be reasonable. That takes us then to should be responsible. And I'm here repeating myself a bit, but I think this message, this ethical perspective is something that has to be repeated again and again and again. Aim your projects for the flourishing of Earth, a common good for all people, species, and natural systems in which we are so totally enmeshed. Aim throughout to minimize adverse effects now and into the future. This is something very important to minimize, continue to think of ways to minimize adverse effects. Remain accountable for your decisions. Remain accountable. Be open. Be totally open to what's going on, what you're doing, and be able to explain what's going on. And in many cases, explanations might have to be detailed, but somehow you're going to have to whittle down the explanation to what is understandable. Be responsible by persisting and working collaboratively and not closing yourself off from any other specialization or way of knowing, because there's so much at the nexus of these three concerns. And then I would say, consider Pope Francis's views on responsibility in his encyclical Laudato Si. And in that encyclical, he calls people to live a life of virtue. And I'm going to suggest that you consider this individually and collectively with the members of the team with which you're going to be working. And here are some of the points that he brings that I found in reading that encyclical and looking for what he meant by living virtuously, because he's not explicit about that. But one of the points that he makes in Laudato Si is we all need to be open to the awe and wonder of this planet, of the ecological systems within which we function, of other species, and to think deeply about them and our relatedness to them. We need to be grateful to other species and systems, how we affect them. Ultimately, for those who believe in God, to be grateful for God for making them possible. And of course, in other world religions, there are many ways of expressing gratefulness and thankfulness. I think constantly of some of the Native American tribes with which I'm familiar, and how before they even kill an animal or they drink water or they go into a forest, they ask for permission and they express gratitude to them. And I think that's, in the Western religious traditions, we give thanks to God for food, but in Native American and some other traditions, there's a thankfulness for whatever it is we are consuming for the necessities of life, because that's crucial in those spiritualities. To be humble. Again, I think that when we're thinking about innovation at the nexus of food, water, and energy, we have a lot of opportunity to be humble toward one another and for the skills and knowledge that they bring to the conversation. To be respectful of one another as well, and to carry that respect on to every other group of people with whom we're working that are going to be affected in one way or another by the kind of technology or innovation that you're going to be proposing. To be protective of the water, to be protective of the land on which food is grown, to be protective of the air so we can breathe it. And not just we, but other species as well. We all need clean air to breathe. To be compassionate. Now, I don't know how you show compassion to water, but I challenge you to think about it. Certainly, the constituents in the water, and the lakes, and the ocean, and the rivers, and so forth. I know efforts have been made to show compassion in the Milwaukee and the Kinnickinnick rivers, to helping to grow, provide baskets for the nurturing of fish, and so forth. I think that's a sign of compassion. To be courageous in insisting on your innovations are going to be oriented toward the flourishing of this planet. And to think deeply about what you're doing, drawing upon your own spirituality, your own relatedness, to this earth and to the systems within which we live, and to other species and other people, as deeply contemplative as we possibly can. And finally, this word of cooperation, its counterpart, collaboration, very, very important. Cooperation, I think, should be the byline of any innovators as you're looking at the nexus of food, water, and energy. Cooperating with one another, cooperating with other people with whom you're going to be dealing, cooperating with other species and systems of Earth. So these are some of the highlights of a virtuous type of living individually and collectively that I found in Pope Francis. And I recommend to you, if you have time, it's online, Laudato Si on Care for Our Common Home. There's a lot of wisdom in there. And as I already mentioned, the first Pope to even use some of the categories that we've been using for years in environmental ethics. So now these are simply my ideas, and I thought it would be fun for you to add some of your own. And I would welcome that. I guess there's going to be a question period, and this is going to be an interactive time then for all of us. What comes to your mind? What's missing? What would you tweak of what I've shared?
We do have probably about 5 minutes.
Just
I think. Take your questions.
Yes.
There we go. Thank you very much for that. That was really really wonderful. And of the challenges, I'd like to add one challenge. So the challenge that I would like to add is that in this area, we really don't know what to do. So the challenge is acting in the face of imperfect knowledge, therefore meaning that at least some of the results of our actions will be quite unpredictable, but that following the current admitting that following the current system is also unacceptable because it's leading us in a direction which is unacceptable. So I think that's as I see folks struggle with these things. I see people want to know what the consequences are. They want to know what the risks are and so forth. And the only way that we're going to learn an awful lot about what we need to learn is by going and doing that. So if I look at the characteristics, I think that you had on the slide immediately prior to this, I think the two things that really strike me, one is courageous, so being willing to act, but also humble in terms of understanding that you are wrong, at least partially wrong, and maybe wrong in some very important areas that you're going to have to fix as you go forward. I think that's one of the big challenges we have here is it would be one thing if we could just do the study and figure out what the perfect answer is and then go do it, but we'll only learn what to do by going and doing.
Right. And I would add also there to be cautious. We know, at least since the Heisenberg uncertainty principle was articulated, that we probably will never have perfection per se. But what I'm saying is we should be aiming in that direction of whatever we do, to have that goal in mind of facilitating the flourishing of our planet or the flourishing of the ecological system, with which we're proposing some kind of innovation. But caution is very important. And I think it was in 1992 at the Rio conference where the precautionary principle was articulated. And I think that's something that's very important for all of us to draw upon, but I think it's especially important when you're dealing with technologies and other innovations, to be cautious. But try after you have gathered the kind of information and you've thought it through, with this altruistic approach that you're taking, and then, try it out. And that's why I say there are times when you're going to have to monitor and then maybe tweak what you're doing. So being on top of something, it can never be something to start and leave. So thank you very much. Right. Yeah. I think it's important to articulate your own clearly as possible, and then welcome the input, of others and see what happens. I think earnestness becomes a very important characteristic of people who are working in the field. Transparency, Again, I keep coming back to openness. And respecting other people's perspective. That will go a long way, I have to tell you, it's a bit funny, but some of you might have already experienced this, but I've had engineers who have gone through the interdisciplinary minor for environmental ethics. And I've had them come back to me and tell me that their companies really like to introduce them at meetings where there are some contentious ideas or proposals being made, because they then can present an ethical perspective to that particular problem. So, but they've done it very well, and the engineers have been happy they've had that background, and they've also been happy that their companies value them for it. So, but I think openness and being honest about what you're doing, what your perspective is, people like to be able to identify with you, and some also like to share their own perspective. It could be a spiritual perspective. And that's helpful. I think it's helpful and it's healthful for everybody to be open and transparent and to admit where, well, we don't know this perfectly, or we have these uncertainties, but this is going to be a better solution in the long run for what we're aiming to do here with this view of the flourishing of the planet. So, okay. You're welcome.
Okay, I'd now like to introduce our second and final panel of the day. If you could take your seats, please.
The end of the day is tough.
Yeah.
As I said this morning, it was very important to all of us on the organizing committee to involve students in this event. And so I'm very pleased that our moderator for this second panel is Chrissy Wabashevsky, a graduating third-year student from Marquette University Law School. Her comment, "Diversions from the Great Lakes out of the watershed and in contravention of the compact," was recently published in the Marquette Law Review. As someone who has read it, I can tell you it was excellent. And in August 2017, she will begin a one-year clerkship with Justice Rebecca Bradley at the Wisconsin Supreme Court. So I'll turn it over to Chrissy, who will introduce our panelists.
Thank you. All right, good afternoon, everybody. I'm very excited to be here today. I'm delighted to introduce our three panelists. So I'll start just very, very briefly, and then I'm lending it to you guys to sort of fill in the gaps that I leave behind. But immediately to my right is Michael Kellerman, and he is a manager of environmental engineering at InSinkErator, where his focus is on freshwater or wastewater treatment infrastructure. He also is a technical reviewer of various publications and also oversees research projects at the Water Environmental Research Foundation. Next to Michael, we have Dr. Paul Block. Dr. Block is an assistant professor of civil engineering and environmental engineering at the University of Wisconsin-Madison, where he teaches fluid mechanics to undergraduates and hydroclimatology to graduates, which I have not had much experience in, believe it or not. And then he also focuses his more personal research projects on a national, international, and also a local nature. However, the primary focus of that research is in Chile and Ethiopia. And finally, we have Sarah Gears. She is a staff attorney at the Midwest Environmental Advocates, where, by many accounts, she is not just an environmental attorney, but also an environmental warrior. She was, before she went to the Midwest Environmental Advocates, she clerked for Justice N. Patrick Crooks at the Wisconsin Supreme Court. And while she was in law school at the University of Wisconsin-Madison, she was also an intern at Midwest Environmental Advocates, as well as the Wisconsin Department of Justice's Environmental Protection Unit. There we go. All right, so I'd like to turn it over to you with just a small prompt, which is I'd like to frame our discussion because the three of you sort of hit the marks of private sector, nonprofit, and academic. So you bring kind of a unique perspective, I think, to our discussion this afternoon. And in particular, I'd like, if possible, you guys to frame your introductions by identifying the branch of the Nexus with which you most intimately identify and how you operate in that space.
So I have a unique role at InSinkErator. If you think about it, food waste and wastewater treatment include both food and water, right? So let me take you back a little bit. 1 year after Mill Organite went into production, John Hammes, right down the road in Racine, Wisconsin, invented the garbage disposal. And InSinkErator has been there ever since. So 80 years of manufacturing disposers. We're now the world's leading manufacturer. During that time frame, think of the evolution of wastewater treatment from the sanitation plant to the sewage treatment plant to the water pollution control plant to the water reclamation plant, and now we're calling them the Water Resource Recovery Facility. It's an interesting paradigm because now, after I worked in the public sector for almost 20 years treating wastewater, I came to InSinkErator at the perfect time for a company that makes a product that Had it never been invented before, today would be the perfect time. And that's because what is getting so much emphasis today are three things, three environmental megatrends: food waste reduction, food waste diversion from landfills, and thirdly, the water resource recovery facility, where you're creating clean water, energy, and fertilizer. And disposers fit perfectly right into that. The last comment I'll make is that there's a difference between food waste and wasted food, right? So the USDA and the US EPA said that we want to reduce food waste by 50% by the year 2030. They want to focus on reducing the avoidable food waste, right? Because 40% of the food waste we produce actually goes to waste. But then contrary to that, think about properly managing the unavoidable food waste, such as your disposer or the grind energy that I mentioned at lunch. So with that, I'll just say starve a landfill and use your disposer.
So I'm an academic, which means I don't get to claim any of this great practical experience, nor has anyone ever called me something warrior. So I'm getting to sit between these two. I also did make some notes, but now I feel like I should probably X them out after Dr. Jamie Schaefer's presentation, which was deep and esoteric, and this, I'm afraid, is a little shallow, perhaps. But I'll continue nonetheless. Identifying my part of the nexus is certainly water. So I'm in water management. Dr. Griffin showed that nice nexus. For me, it's hard not to see the water bubble get bigger than the other two, but I'll try to check my bias at the door a little bit. I have some friends in economics. That might be an oxymoron, but I have some friends who are economists who say that they have to watch their ego a little bit, because economics, they say, is a natural integrator, right? All things come down to economics. And while I don't disagree with that, I also think we could say something about water in that same regard. I think of water as the common denominator. It is involved in all things and in all processes. And if you truly take that analogy, a common denominator, if you took that away, right, so there's zero, that's an infeasibility or an impossibility, right? So we can't have things without water involved in them. I think many people, and this is a little contrary, I'm looking for Dr. Griffin, but I think it's a little contrary to what he might have said earlier, is I do think people have been thinking about the nexus somewhat, even if they don't know it or admit it, right? So we've always thought about agriculture and water together, and we've thought about energy and water together, and the three of these. But there has not been given enough attention to that, particularly at the forefront of this research. So I'm very glad that it's being given more attention by funding agencies, by utilities, et cetera, et cetera. I think one of the reasons it's getting so much attention now is because that nexus, or aspects of that nexus, are getting stretched, right? And so it's when things become stretched or perhaps a little more scarce, they start to get attention. That's natural, I think. And part of that is not that there's just changing in demands and preferences, as someone said before, but there's changes to supply, right? And so we're seeing both changes in supply and demand happening concurrently, which, when you think about that from a nexus perspective, is definitely challenging, provides some real questions, and then begins to present what we call, in water at least, some of these wicked problems. We don't even completely understand the problem, nor do we have any capacity to understand all the possible consequences of that problem. I also think that fuse is in itself a little bit limited, right? Food, energy, water. We could throw other things in there, right? We can throw environment in there. That's not a part of this. We can throw health in there. That's not necessarily a part of this. We could also throw in the whole human dimension, right? Now, I don't think any of us would say we look at this nexus in absentia of those things, right? But I think they're important to acknowledge up front. The human dimension is probably the hardest piece of this, right? Water is fairly rational, right? Agriculture is fairly rational. Humans are irrational, right? We model humans as rational, but we are not. None of our decisions in life are rational, okay? I don't mean that to be depressing. but it is the reality, right? It's the reality. So a lot of my work is at the intersection of climate and decision-making models, be that agriculture, be that water, be that health, and then looking at some of the outputs of that, economic, social, et cetera. This is across scales. One of those scales is at the basin scale, and so some of that work, which we've been fortunate enough to have one of these NSF Infuse projects to look at, is in Ethiopia in the Nile Basin. So there we're looking at strategic hydropower development, trade-offs with agriculture, and then, of course, implications to food, to water, and then hydropower itself is energy. So thinking very deliberately about how these things interact, but then also thinking very deliberately about what are the downstream effects, right? We have, in this particular case, downstream countries that would like to rely on that water also. So if we change the course of this water, and this is not part of this work, but one concept that's been talked about today is reuse of this water, right? And keeping it in the same place and reusing it. Well, if we do that, that means people, resources, environment downstream do not now have access to that water, right? So what does that dynamic bring to us? And then also thinking about things at the local scale, at the farm scale. We have some work, which is just beginning, so please don't ask me too many questions about this, but some work in the central sands, right? So very productive area for agriculture, groundwater pumping, right? Lakes, trout fishing, aesthetics, real estate, all these things have an interplay. And so there's a nexus question there. So I'll kind of wrap it up there, but one last thing that I'll say is many of the things that we've been discussing today require an investment. Maybe it's a human capital investment, or maybe it's a financial investment. But those things also are resources and have a limited resource to them, right? So there's just like there's not an unlimited supply of water or land or air, we have not an unlimited supply of financial resources as well.
So thank you, everyone who's gone ahead of me today, including all the folks who spoke earlier today. I've definitely had a lot to think about, and it's changed, I think, just like Paul said, it's changed what I wanted to say as part of this panel. So I'm going to keep it pretty brief and just tell you a little bit about my work and my organization and how it fits in this nexus. I'm a staff attorney at MEA. We are a nonprofit environmental law center that works to ensure clean water, air, land, and government for this generation and the next. So referring back to Dr. Schaefer's presentation about stakeholders, we provide legal and technical support to the to various stakeholders, the consumers and organizations and businesses that consume water and food as part of the food, energy, water nexus. The tactic that we take to try to influence positive change in agriculture in particular, and also to protect our water resources, is to hold agencies and producers accountable, basically users of water resources, agricultural producers that affect water resources, accountable to environmental laws that were designed to protect that environmental commons. What we have going on in the central sands, for example, with a lot of pumping of groundwater and impacts on streams, individuals' private wells, et cetera, that is, a tragedy of the commons type of situation that we want to help address by speaking up for the other users that are not that might not be stakeholders at the table in some people's view of the situation. So I'll talk just really briefly about something that's come up already today in Russ Rasmussen's comments about what the DNR is doing to address water pollution issues associated with agriculture in Kewaunee County, and also something that I mentioned at lunch as well. We've worked in Kewaunee County for about 4 years to try to help residents get secure access to clean drinking water. Because in that part of the state, we have a vulnerable groundwater aquifer and a lot of manure application on farm fields that leads to groundwater pollution by pathogens and nitrates at really high levels. So through by working with residents and listening to them and sort of their needs, and trying to find, trying to partner with different agencies and other stakeholders to find solutions. We've taken some legal tactics to try to bring about change, but by working together with the whole community, I think we've created more dialogue around the problem and helped drive innovations which aren't all, they're not all well accepted. For example, the biodigester proposal has had sort of a mixed reception in Kewaunee County, but it is driving change, and that's what we strive to kind of support in our work at MEA.
Thank you, Sarah. I think on that note, it might be nice for us to turn to your experience working with the DNR in particular, and Michael, I think you can also attest to this, different regulatory agencies and regulations that affect your business, and I wonder if you can all kind of speak to that.
Yeah, so when I came to InSinkErator 10 years ago, there was no such thing as a landfill ban on organics. It was something that was going on in the EU with the landfill directive. Now there is Massachusetts, Rhode Island, Connecticut, Vermont, and then California, although California would tell you it's not a ban on organics, it's a goal to reduce organics going to landfills by 75%. So that has really impacted what we are doing as far as our marketing strategy to help promote the use of disposers to help keep the food waste out of landfills. The other thing on the regulatory side is, we kind of talked about it this morning, the treatment plants, they're faced with increasing constraints on their budget for capital improvement and things that are necessary to help keep them in compliance and in operation. And yet this idea of becoming energy independent through bringing food waste in as an energy feedstock for their digesters helps them to maybe spend more funds on those efforts towards compliance. So actually, mandates can be a huge driver, and it's certainly impacted what we're doing, and that's kind of why we developed Grind Energy as well.
Great. I know, Sarah, if you'd like to comment.
Yeah. So how I see our relationship with the DNR is, I think we certainly strive to work both collaboratively with the DNR, but then we also do see ourselves as kind of, a watchdog on that agency to be sure that they really are, zealously defending our environmental commons and in protecting public health. So we were initially founded in 1999 to sort of fill the void created by the loss of the Public Intervener's Office. I don't know if any of you know what that is, but it was an office of the government that was created to basically serve as a voice for the environment and the citizens in the state of Wisconsin. So they were there to make sure that decisions of the state government were not having a negative impact on the environment or public health, and if they were, or if those decisions might have such an impact, then the public intervener would get involved and push back. So that's sort of the role that we see ourselves in. So we try to work together to support the DNR. We certainly try to, reduce the burden on them as much as possible in terms of, having our own intake program and helping citizens get the information and resources they need. But then we do also kind of watchdog and, check the permits that they're issuing and make sure their decisions are complying with environmental laws. We certainly advocate for an agency that is adequately funded, adequately staffed, and given adequate authority.
Thank you. And I'm wondering too, Michael, if you could just talk a little bit about the steps your company takes to sort of promote and address some of the current environmental issues that arise within the Nexus.
Boy. I've had the unique role as a former wastewater professional to actually get the opportunity to engage with wastewater professionals like Glenn Diger. I engaged with the technical audience, the influencers, the government agencies as a liaison to help understand what the concerns or the knowledge gaps might be for research and then to actually try and fill those knowledge gaps with academia through research. It's provided me the unique opportunity to actually give back to the wastewater industry in actually a more rewarding role than actually being an operator of a treatment plant. And I say that because helping the industry move forward with water resource recovery, helping to become energy independent, helping to capture nutrients, this whole paradigm shift, if you will, the rebranding of treatment plants to a water resource recovery facility, making clean water, energy, and fertilizer, it's given me a venue to actually help educate consumers that oftentimes don't know where their toilet goes, let alone their disposer. And yes, they do go to the same place. So, I don't know, does that answer it?
I think it does.
Yeah, and I can still be a water professional, and I do. I stay involved with WRF on the issues area team to help decide where we're going to fund research projects to help treatment plants look for energy efficiency and energy gain, as well as oversee the final product as a reviewer. I've reviewed several manuals for WEF and WRF as well. It's a great way to give back to the industry.
This is a question for the group. Before our presentation today, Michael had sent me a slide that had described, as you had said, 3 areas, 3 trends, mega trends. And one of those trends really was, well, not in so many words, was the food water nexus, or food energy water nexus, rather. And I'm wondering if all of you can contribute to this. Is it a trend, or is it really something that you see lasting in terms of discussion and focus?
I think we should have it solved by next week.
Okay.
Go ahead.
Just a few words on that. Yeah, is it a trend? Is it a fad? If, you know, from a very selfish perspective, I can say, well, National Science Foundation and others are funding this, so I'm going to jump on that trend, right? Or in that fad. Again, I'll just reiterate what I said before. I think this is something, it's always, or almost always been in existence, right? But it is getting more attention now, probably because it's being stretched, right? Or there are scarce parts of this. And we need to be much more creative in how we address, you know, these questions, right? And we got some great examples of how this is being done throughout the day as well. So I would not say that it is a trend. You know, I would say that it is real and it is pressing. And if we map onto this an increase in extremes, which we are likely to see in the coming decades, it will likely only be exacerbated, right? We are seeing more and more disparities, right? Certainly economically, when we look internationally, these are going to be more and more exacerbated. You know, we've seen riots over food crises in past years, right? Over the price of bread, right? These are not going to go away, right? How we frame them, what we call them, does that change in 10 years? Maybe. But to me, these underlying challenges are going nowhere. And I don't mean to paint a bleak picture, but
I would also point out that, you know, it took us a couple decades to get recycling right. And now almost every home has the blue bin that's bigger than your garbage can, right? In my house, I set that out every other week. And I actually wish that it was the other way around, because I hardly ever fill up my garbage can because most of my food waste goes down the disposer. But the point I'm making here is that it took a long time for people to get it right on recycling. And my parents still, to this day, don't put stuff in the recycling bin. And yet, after recyclables, the greatest proportion of our landfill waste is food waste. It's as much as 20 to 30% after recyclables. So it's the lowest hanging fruit, and it's what's coming next. And so as municipalities look to reduce costs and states look to keep the organics out of landfills, that's where it's going. And as I said, 5 states now have mandates that did not have them 10 years ago. There's 3 or 4, well, Maryland, Florida, Minnesota all have some kind of a ban in the works. So, you know, we're very rapidly approaching, you know, a third of the U.S. has some form of a landfill ban.
Yes, Sarah, do you have anything?
Oh, just very briefly, I'd agree with those comments and just say that I think it's part of a larger movement that I hope kind of builds to consider even more than the food, energy, water nexus. And I think Paul mentioned this earlier, that we also have to consider impacts on air, species, et cetera.
Thank you. Great answers. I'd like to shift the focus a little bit, and Dr. Block, you in particular had mentioned sort of the focus nationally and internationally on the Nexus, and I'm wondering if you can speak at all to how the Midwest in particular compares in that field.
Okay, so I preface it saying I can't say too much about Central Sands, but I'll say a few things anyway. First of all, I think most of us probably agree in this room that there is no real one-size-fits-all. Right? And so it's going to take a variety of different approaches, and that's a good thing, right? It requires all of us to be creative. That also applies when you look at situations in the U.S. and situations in other countries, right? There are different regulatory structures. There are different things that are allowed or disallowed in different places. I think a lot of this, so I'm an engineer, so I do think about infrastructure, but I also think a lot about management and non-infrastructural approaches to some of these challenges. And I think that's very, very important when you think about limited finances as well. So, for example, in Ethiopia, real quickly, some of the work that we do is we try to encourage farmers and water managers to take advantage of seasonal climate information. So can we say something about the coming season, precipitation, stream flow, et cetera, and take a proactive approach to that? Maybe plant something different, do something different with your reservoir, et cetera. And in some places where we work, in Chile, Ethiopia, that can be readily applied. In the U.S., right, we have a lot of legislation on the way our reservoirs are operated. U.S. Bureau of Reclamation, Army Corps of Engineers has to follow certain, what we call rule curves, for how those reservoirs are operated. I'm not saying it's a bad thing, but they have very, very little wiggle room, right? There's a book. They follow that book. So those are different approaches for different countries. I simplified that a little bit for the essence of time. But maybe water markets, the way water markets function in the Western U.S. versus Australia versus Chile, those are different because of the regulations or the lack of them thereof. So if we think a little bit about bringing it back to Midwest and Central Sands, right? We have the water, we have the energy piece there. We think about food production and transportation. We have to include maybe Chicago up to Minneapolis, this whole area, right? This is all involved in Central Sands production and delivery and transportation. So all of those things get wrapped up in there. So it is complex, but I think we can break this apart and we can address certain things. And it's not that there's a solution that solves all of these problems simultaneously, right? I think none of us are not that naive, but perhaps worth saying. We do one thing at a time, or try one thing, and maybe don't be afraid to try some of those things, as was said earlier, and see what happens, right? And move forward, perhaps courageously. So I don't know if I really addressed that as you had intended. Maybe I talked around it.
No, I think you answered it, and I think the notion of creatively and courageously addressing these issues really comes to the heart of a lot of what we've talked about today in general. And I think to Dr. Schaefer's point about collaboration, I think I would be interested to hear from all of you about what you think of collaboration, either between, like I said, Michael comes from a private sector position, and Sarah, you come from nonprofit. How do you find that you work together, not necessarily exclusively to your individual roles?
Sure. I'll start. So now that I've been at MEA for like 4.5 years, I've been involved in different projects involving kind of different industries, and so had opportunities to compare in terms of successful collaborations and maybe less successful collaborations or more difficult collaborations. I would echo Dr. Griffin's comments about trying to get all of the stakeholders to the table earlier in the process before the problems and the divisiveness is really entrenched, and bringing in truly all of the stakeholders. So again, referring back to what Dr. Schaefer was saying, making sure that you're not just including the producers as part of the conversation, but also the consumers and maybe some of the stakeholders that you might not think about initially, like the environment generally. Yeah, again, I don't know how much that actually answered your question, but
no, I think it does. And,
yeah.
and in particular, could you speak to? I had come across a La Crosse Tribune article that had spoken that attributed a lot to you about a sand processing plant up in Monroe County, and you had discussed the boom and bust nature of sand fracking and energy industries in general. And I'm wondering if you could, my specific question is, do you find that energy companies can be good neighbors? And do you find also that they're willing to collaborate with nonprofits like yours?
I'd say in some cases, sure. Just like in any, I think there are examples of, and Dr. Griffin and I were talking about this, large agricultural facilities that are good neighbors and, getting ahead of the curve in terms of what they're doing to protect neighbors' public health, water, et cetera. And similarly, I think there are some, sand mining companies that are doing more, that are in it for the long haul, and that are doing a better job of protecting their neighbors from some of the negative impacts of their business, and also protecting the resource long term. And so just to clarify about, but the nature of that industry, of the mining industries in particular, being sort of ebbing and flowing quite dramatically with the market, is relevant when you talk about environmental protections, because some of the environmental programs, the wetland one, for example, depends on a business being around for a long time and being financially solvent for a long time, so that they have the money later on to do reclamation and get the land back in the type of shape it was in before, or in the case of wetlands, to do restoration, which can be quite expensive.
Thank you. And I don't know if either of you would want to weigh in on the collaborative.
I would just hint at the value of networking through trade associations. The other one I would mention is connecting with thought leaders and subject matter experts through things like LinkedIn. It's been a tremendous boon for me in helping to overturn some prohibitions of disposers in Raleigh, North Carolina back in 2008. I had been reading a water environment research article from Kevin Keener and Joel Ducoste on fats, oils, and grease in sewers. We ended up using this gentleman as an expert witness, and we overturned the prohibition in Raleigh within 6 weeks. And probably within about 2 months, we're going to submit a journal article that's taken the last 8 years to put together over 51 references on understanding what's happening in sewers with fats, oils, and grease. But it happened through collaboration with subject matter experts and trades, Water Environment Federation and others, where these people are, you can get your answers.
Just briefly, I think, collaboration, no one in here would disagree that that's an important thing, right? But it's often means moving out of our comfort zone, and it often means slowing down the process, right? So we have one project which is extremely exciting, which we're working with some farmers and trying to offer them some certain information. So as part of this, we need to understand their behaviors. And so we have a group of ethnographers that are working with us on this. And I'll admit, I had to go look up what ethnography actually means, right? That was my limited knowledge on ethnography, right? So I am slowing down the process, but hopefully in the end, it will have been worth it, right? For us to, and I don't know that the ethnographers knew everything about civil engineering either. So it goes both ways, right?
What is an ethnographer?
So ethnographers really do study the way that decisions are made, the way that people behave, the way that they act. And so these folks will, again, this is a project in Ethiopia. These folks will go live in different villages for a matter of months at a time and see how the governance structures work in those villages, try to understand how and why information is passed and how people do come to these different decisions. And I have to add this on, I'm sorry, but so I'm thinking, I continually think about, we build models as engineers, right? And so if your model fails, that's a bad thing, right? So we have to get a model that actually works. And I said, well, what if this outcome happens versus this outcome? And the ethnographer said, well, it doesn't matter to us, right? It's interesting either way. So for them, it's a win-win. It doesn't matter what happens, doesn't matter the outcome. They can write their book or their article about it because it's interesting.
Yes.
I'm not so sure that's the case for all the rest of us.
I don't think so. All right, thank you. I'd like to turn now again to Dr. Schaefer's discussion about ethics. And I'm wondering if you can identify perhaps one or two ethical dilemmas that we are seeing right now or that we will potentially see within the next 5 or 10 years within the Nexus.
The Federal Trade Commission came up with greenwashing guidelines, and legal folks at Emerson have essentially made it very difficult to make any environmental claims about a product. And a lot of it has to do with the variability of your message, right? There are no absolutes, a lot of generalities, a lot of trade-offs. And so when people talk about sustainable solutions, they tend to only really talk about environmental or only economic. They forget that there's all three. And you know what? There are trade-offs. And we got to be willing to talk about trade-offs and realize that there are pros and cons with all solution. And to your point, there's no one silver bullet. I think that was said earlier as well. You need multiple solutions for all problems.
I'd say something that's just a core part of my work at MEA is making sure that the cost and burdens of doing business are not passed on to a select population of, for example, in the water food nexus, folks who live in rural areas and, might have a limited income and are very negatively affected when, their water supply becomes contaminated and they are responsible for coming up with over $10,000 to replace it or find some other fix. So the big ethical issue that we struggle with and we try to, push back against or raise awareness about is, preventing externalities from being passed on from businesses to a select group of consumers that might be more vulnerable consumers without kind of spreading out those costs.
Thank you. And Dr. Block, did you?
I would agree with that. I think these externalities are huge, that we have to try to quantify those and identify those. And also thinking, yes, about these different economic classes and being very careful to make sure that, certain economic classes are not being overly burdened, I guess is a better way to say it.
Great, thank you. Well, with that, we are just out of time for moderated question and answer, so I'd love to open it up to the audience. And if anybody has questions or comments, yes.
Yeah, I'd like to just maybe do the inverse of what you guys were just talking about and go to, we talked about disruption in marketplaces with innovation. Michael, your business is disrupting the traditional waste management companies. Waste Management, Republic, Waste Connections. They don't want you to take 30% of their product that's going to their landfill. Their business model is based around that. Now they're moving, they're going to have to move, but they're going to keep it slow, even though it's for the commons, and everything is great except for their business model. So ethics, business model, disruption, and they're powerful. That industry is powerful. So what are you seeing working with them?
There's more than enough food waste to go around. To be honest with you, if you're talking about 40 million tons or whoever you go to for an estimate, it's a lot of waste. It's also the heaviest fraction of the waste, so it means they've got to spend money picking it up and transporting it, and also tip fees, which is a conundrum because some cities own the landfills and they get revenue off the tip fees. It's highly variable. And that's what I said earlier, you can't speak in absolutes. Everything's different. I would tell you that in New York City, the reason that there's still a commercial food waste disposer ban is because the city operates all of the carters for residential trash, but it's private carters that haul the commercial trash. And the commercial carters would have everything to lose if some of the food waste was taken out of that waste stream, whereas the city would have everything to as far as a cost perspective, lose if it went to the treatment plants in their mind. It's complex, but actually Waste Management just wants to haul it, and they just want to put it in the ground. And so there's more than enough trash to go around for them to be in business for a long time.
Thank you. Anyone else? Yes.
Hi, excuse me. I'm not a water person. I'm going to ask this as a layperson. Could you talk a little bit more about the logic that of the food waste belongs in the water system rather than in landfills? I asked this, so I live in Glendale, where we actually have a mandate. Everybody's got a garbage disposal, and I really overused mine when I moved there, and it actually twice backed up and had a flood in our basement, and I just stopped using it at that point. And it seems to me that the messaging about keeping bad stuff out of the water system has been really good. So I know not to put my pharmaceuticals in the toilet, etc. But I've also taken that message to mean that I shouldn't put food solids into my garbage disposal and therefore into the water system, because it has to be cleaned out of the water. So the logic that I have at this point as a consumer is it's better to put it in the landfill than to put it in the water system. So can you just talk about what's the rationale?
Absolutely.
I think it must not be an incinerator that you have. So maybe you want to check the actual unit.
No, actually, I'll just start off by saying we do a poor job of educating the consumers on how to use a disposer. And from my learnings, it seems like people, when they have problems, it's probably from improper use. And that's this. They'll load up the chamber or the sink and say, oh, it's time to use the disposer. My sink's getting full. It's running over the top. They'll turn the disposer on, and then they'll turn the water on. And then as soon as they see the food waste disappear, they'll turn the water off and the disposer off. What you really want to do is turn your water on first, turn your disposer on second, and then add your food waste gradually. Let it grind until you don't hear any food waste anymore. Turn the disposer off, and then let the water run for a few seconds. So when you talk about sending food waste to the treatment plant instead of a landfill, think about it this way. Food waste is 70 to 90% water. Why are we handling this as a solid waste? Its density is the same as water, 1 gram per mil. So when you grind it up very fine, it's going to be very efficiently transported through the sewers, provided you have the adequate 2 feet per second velocities that most sewers are designed for. So I would just say it's not really solid anymore if you're using the disposer right and grinding it fine. The last thing with regard to pharmaceuticals, it always amazes me. My undergraduate degree at Purdue was environmental health. And pharmacology, we still prescribe, right? So we take in these pharmaceuticals, we excrete, over 90% of it. These take-back programs to keep it out of your toilets from, flushing or getting rid of it that way, those are all great. But the bottom line is, as long as pharmacy is the way that it is, we're going to excrete most of these endocrine disruptors and birth control pills, even caffeine, all the things, the painkillers, benzodiazepines. These are all things that our society is taking and we're excreting. So no matter how good a job we do at take-back programs, we're still going to be putting this in the wastewater stream.
Thank you. Anyone else? Yes.
So I've got a question about Central Sands. What do you think is driving the big explosion in the irrigation? Is it policy? Is it markets? Is it technology? What's going on there? Does anybody know?
You want to go? I'll just very briefly respond, because I understand you're kind of can't really talk about it, correct? Because you're doing research.
I can talk about it. I'm just ignorant.
The reason I was asking is, so on that side of it, I am a little bit ignorant to, basically not the best person to talk about it, but the heavy irrigation in the Central Sands area of Wisconsin has been going on for a long time. And so it's been a gradual increase over maybe 50, 60 or more years. And it's partly because of the concentration of, potato and vegetable growers in that part of the state. And since I've gotten, kind of involved in this issue, what we're focusing on is the need to change sort of the regulatory program so that we are so that we're preventing this sort of tragedy of the commons from being perpetuated by looking at, how much water can we sustainably pull from the aquifer? Can each individual user sustainably pull and still leave some there for the streams and the other private well users, et cetera?
I'll just add to that. So I'm not being funded by anyone for this work, so I'm free to say what I would like. And I think I think the farmers here really do get a bad rap sometimes, and unjustifiably so. The policies are set up, I believe, for farmers to produce as much as they can, right? And there is no disincentive for them to pump. Actually, there are incentives for them to pump, to produce these crops, to produce a high yield, right? So farmers are working in the system that is set up for them. That's my personal belief. I also think, if somebody showed India before as well, right? And I think in parts of India, northwest India, if you can just see the groundwater going down, right? And again, it's because of the system that's been set up. They don't pay for water, they don't pay for energy, right? So what's the disincentive to pumping? There isn't any, right? So you're just gonna pump and produce your crop. So I think we have to rethink the system, and it's easy maybe to sit back and point fingers or say, it's obvious that you're pumping here and this lake right here is being depleted, right? And we know those things are connected, but it is complex, right? It's complex, and it's not just about the water and being extracted and being drawn from another source. It's about the regulatory system that's set up on there and what the DNR can and cannot do about that, right? There are lots of things that are tied up in there.
We have probably time for one more question. All right. Well, on that note, I'd like to thank our panelists, if all of you can join me in thanking them.
Thank you.
And I pass the baton back to Professor Strickling.
Thank you, Chrissy. Thank you to all of our panelists. We've come to our last session of the day, and I'm not going to tell you what the weather is like outside, so don't ask if you had any questions about that. It's 42, and the rain is coming in. But I did want to give us the opportunity to talk to each other one last time about what we've heard this afternoon. So we did set aside some time for a final group discussion of the topics that we've heard about both this afternoon and I guess all day. And I think rather than try to move back into the breakout room, it probably makes sense just to handle this as a full group discussion. So I again have a couple of questions that we can talk about and hopefully stimulate some conversation about. And I certainly mean to act during this as a facilitator rather than anything else. So at lunch, we had listed some of the potential synergies in the Nexus. But what I'm hoping to explore now is some of the stressors or controlling factors, barriers that have to be overcome. In other words, when we go back to our individual organizations, whether academia, industry, government, or non-government organizations, how can we tackle some of these interconnected challenges? What sorts of things do we have to overcome? So does anyone have any comments on that when you think about taking some of the lessons from today back to your organization? What makes you nervous? Yes, Tim.
I think for one, a lot of what we heard today is a different way of addressing what are fairly serious, either societal or environmental problems, but it's a different way, which makes people uncomfortable right from the start. It's like, I've never done it that way before. It's the same, in education, doing intensely interdisciplinary work makes people very uncomfortable just from the very first minute, because
certainly it can be difficult to overcome that siloed way of thinking, to use what some would say is a pejorative term about it. But it's also difficult, I think, to give up a sense of control over your own work and decisions and approach to a particular problem, and to open yourself up to the other perspectives that other disciplines or folks may have. Other responses to this question, hurdles, barriers that we have to overcome. Dan.
I'm worried about political will to do these things, and I think these things, if you look at the Clean Water Act as a model, and the establishment of the EPA, we really don't celebrate the great accomplishments of that legislation and what it's meant for our lives and for the country, and I just don't see the political will to establish these great pieces of legislation that really are game changers.
Yeah, the comment had to do with the lack of political will to address some of these grand challenges. And what I often say to my students is the creation of the EPA, the Clean Water Act, many of these landmark events were driven by huge environmental crises events that occurred in our history, whether going all the way back to the Dust Bowl, triggering grazing reform, to the Cuyahoga River catching on fire, triggering the Clean Water Act, or the amendments anyway of 1972. And until something like that happens, maybe it will be difficult to generate political will to move forward. That's a very good comment. Other reactions? Matt.
Yeah, this thing's not going anyway. All right, I'm kind of loud anyway. So for me, what I see is it's very easy to be an operator, right? It's a little more difficult to be an innovator. You're kind of rocking the boat. You're challenging an established way of thinking in some cases. Sometimes the barrier is you're the new dog in the room, the younger person, and sometimes it's just you're the person who's least accepting of that's how it's always been. So I think fundamentally getting out of the comfort zone and to some extent you have to put aside the fact that you can do 100 things right, but people tend to remember you for the thing you screw up, and be willing to take a risk if it's something you truly believe in. Now, granted, that's again falling back on a statement of belief in that the way you're thinking is true, but a lot of times you have to be willing to take a risk and just put it out there, and also check your ego at the door. That's at least been my personal experience. Be receptive to the other thoughts at the table and understand that collectively you're going to move together better, and trust that you will, kind of following that little invisible hand principle of economics. So that's kind of my thoughts on it. Barriers are a lot of times fear-based. How is it going to be perceived if it doesn't work out?
Yeah, you might be remembered, as you said, for the wrong reasons if it doesn't work out. Yeah, absolutely. Michael.
To Dr. Zittimer's point, I think we lack the political will because we take for granted so much of what we have. Inexpensive food and water and energy, right? And so things as simple as using a disposer rather than putting it in garbage, it's like, why bother, right? Everything's easy. Go to the store and get all you want. Look at the bountiful blessings we have when you go to the grocery store. People don't want to know that as much as 25% of that stuff on the shelf is probably getting thrown out just so that they can keep good-looking stuff out there for us. We have it so good that we take it for granted.
Yeah. Other reactions, barriers? Yes.
The
Yeah, so this goes back to somebody used the example or the analogy earlier today of being a T-shaped person, right? You need that depth, but you also need that breadth to bridge the gap between the specialties. And so if you don't have both of those things, if you just have the depth, you're not going to be able to talk to others who are trying to do the same kind of work from the perspective of other disciplines. At the same time, if you just have the breadth but no depth, that's not good either. So you need both. I think that's a really good point. Yes?
I think that's a good endorsement for the co-op program.
Tell us more.
Well, thinking most people here are familiar with Marquette's co-op program.
Mm-hmm.
And I've had the opportunity to, participate in that. It's with students from here at MMSD, and just what the gentleman's saying, it gives individuals an opportunity to see how things actually work in society and in employment setting, and teaches them the things that they don't get in the classroom.
That's a very good point, and I should add that the law school has recently established a relationship with MMSD as well, and we're putting our law students in your legal department as well, and we're very grateful for that. I think, as you said, it's a way to make them more well-rounded and see some of the different problems that are faced actually in practice. Amanda, I think you had a...
If I could also just respond to that, as a history professor, to me what you said is an endorsement of the value of a liberal arts education, sort of as undergirding whatever happens in the specialization at the higher levels, that training actually happens to you if you've gotten a college degree in the liberal arts, but you may not have realized that's what you were doing.
Yeah, it goes to that breadth part of the T. Dave. Yeah, and as you know all too well, Dave, the center has recently instituted some formal structures to sort of try to force that collaboration, and I think to the extent that's necessary, and we just have to do that to make sure that kind of conversation happens. Other comments or reactions, questions to throw out to the group? Let me move then to what I had down as a second topic of conversation, and that is Dr. Schaefer's presentation, which, as they say, was something completely different compared to the rest of the discussion today, I think. And I think it was really valuable to have that perspective. Again, as you think about going back to your organizations, have you any thoughts about how you would incorporate some of those ethical themes, being courageous, being humble, being collaborative, that Dr. Schaefer presented? Did that resonate as you're heading out, as we're going our separate ways today? Yeah, please.
I think some of our policies and technologies that we expect to implement in our professional careers may last longer than ourselves, and therefore we should focus on the issues of others, of future generations, and take those into account, and that may diminish the impacts of these policies and technologies that have impact on ourselves.
Yeah, so this goes to her point about the voiceless, right? The voiceless future generations, and making sure we consider them in our decision making. So absolutely, I think to the extent we're mindful of that, we do move some ways down the road that she had laid out. Other reactions to that ethics presentation? Chrissy?
Yes.
And she's a law student. She's having trouble figuring.
I know. You guys aren't unique. I found so much resonance in what she had to say, particularly because I found myself later, as I went through law school, looking for a little bit of depth and meaning to what I was doing here. And I think that is not unique, because I think that a lot of people perhaps get caught up in the grind of whatever they're doing. And I think while in some cases one could say, oh, this sounds like a training exercise, you know, to think about the depth or the ethics of what I'm doing. But at the same time, I think that if you can find ways to connect more meaningfully with what you do, there's longevity in it, then there's meaning. And there's a lot of personal satisfaction that can be gained from it. And I found when I was looking for that, that it brought so much more to my, at least legal education. I don't think that's, you know, one thing. I think you can put that in any place that you look.
Great perspective. So part of it is internal, not just going back and externalizing in our home workspaces and organizations, but taking it and internalizing it and finding meaning that way. Other reactions to the ethics presentation?
I would add that in today's political correct world, to hear a perspective on spirituality in a venue like this as a Christian was very refreshing, and I appreciated it.
Thank you. Other reactions, Amanda?
I'd actually like to pose this as a question to those of you who are in the water industry, which, as I said, I'm not. I was really struck by the one or two lines in the presentation about the meaning of the word resource. And if you're talking about the water as a stakeholder and the land as a stakeholder and the air as a stakeholder, does it make sense to talk about water as a resource? And I wondered, she didn't draw this out, but I read that as sort of implicitly saying there's a fundamental challenge here to water as an industry, that you can't think about water as a resource. And I wondered if you read that as a challenge.
Let me open up that question for reactions.
I don't see it as a challenge. I see water as both a resource and a stakeholder. I think water is certainly a resource. I don't see a problem thinking of it as a resource, but I think you can't exclusively think of it as a resource.
So tell us a little bit more about that, Dan. I think that's very insightful. What exactly do you mean?
Well, it has to be managed carefully because it's finite, fresh water. And so to me, it's a resource that you have to think seriously about and manage very carefully. And so in that way, I kind of put on my quantitative resource hat and say I have to think of it like that. But then I also believe that water is, like Jane said, is a stakeholder. You know, water in itself is a manifestation of God's grace on the earth, and by itself, we should do everything as a creation, as it is a creation of God, to maintain it, maintain the environment. So I think as an engineer, you're always wearing two hats. You have this quantitative resource hat that you have to wear, but you're doing this work because you believe it's the right thing to do, and you're doing it because of the greater good. You certainly believe that water and the environment should be protected and thought of as having, being a stakeholder. I like the way she put that.
I had a real problem with that, considering water as a stakeholder. I mean, my God.
Kind of abstract.
Well, very much so. I mean, if it's a resource and it's a valuable resource, you're going to do everything you can to protect it and efficiently use it. And to me, that makes a heck of a lot more sense to most people than calling it a stakeholder. A stakeholder is somebody you invite to a conference table and you have common interests and you talk. Now, I've got a glass of water here. It hasn't said a damn thing to me.
appreciate the perspective. I want to invite other responses to Amanda's question. Comment in the back, yes. Other responses to Amanda/Jamie's question. Is water a resource or a stakeholder? Does it have aspects of both? Yeah.
One that comes to mind is stewardship. Maybe to follow up on Dr. Dan's, if you believe everything is part of creation, humans are part of creation, water is part of creation, humans are resources, water is a resource, but we have stewardship responsibilities, and maybe that's the connection with stakeholders in terms of water.
Other reactions, Matt?
It's definitely, I think we'd all agree, it's a public good, and there's a lot of reasons to protect it. We may all have different reasons, but I think at the end of the day we agree it's something in that one area is something to be protected. For example, you don't want to focus narrowly on your business model and exploit a resource because you want to have longevity in your business. There's a sustainability aspect of sustaining your business, your revenue streams, customer base you can't exploit and be selfish because your business will eventually fail. Say a brewery pulling too much water and there's no more water, how are they going to make their beer? Or other industry examples are out there as well as personal things, and that's where government fundamentally needs to step in to establish protocols for preserving and protecting, and I think fundamentally that's something that we can all agree is an important thing to ensure that the resource is there for us to use, whatever our intention of use for it is. So from that aspect, I would say it's a little bit of both.
So there's a role for law and policy, maybe, perhaps, in this conversation. Paul?
I guess for me, it's really neither here nor there whether we call water a stakeholder, a holder, or a resource. However, I think what we're doing here is exactly the first steps of interdisciplinary processes, trying to talk about things from different dimensions, trying to understand them and get everybody's perspective on the table. So we may not in the end agree what we should call it or how we should classify it, but hopefully everybody does agree that we are talking about the different dimensions of it.
I think that may be where I end up too. Other reactions? One of the themes I think today was how broad a topic food, energy, water nexus actually is. And it could be even broader. We could bring in climate and health and some of these other considerations that we've talked about. So let me open it up even more broadly in that spirit and ask, is there anything that didn't come up today that from your mind should have, that we should be considering as we go our separate ways today? Or did we just cover it all? That'd be okay too.
Well, I think the ones that you mentioned, certainly health, when you look at environmental engineering as a discipline, where it was sanitary engineering, going back to public health engineering, or civil engineering, public health was always paramount, the driver. And, when I think of water and food, it's kind of drilled into me that public health should be paramount. So to me, it's hard to talk about water, food, at least that nexus, without public health.
So maybe that's something else we should build in here, or that NSF should consider when setting up its RFPs. What else should we include here? Or what else didn't come up that you thought should have come up? Dave.
I thought there should have been more emphasis on how to break down the barriers to achieve innovation, changes in regulations, that we could, that to start operationally taking steps forward. I think there are a lot of discussions of big issues, but I don't know if we took any steps towards solutions.
And that's where the really hard work comes in, right? Operationalizing all of this and turning it into concrete progress on the ground. And I think there's incremental steps being taken in a lot of different areas, but it's sometimes difficult to see where the progress, where the actual progress is. And it's difficult, too, when you bring a large room of people together with a lot of different expertise to get everybody moving in the same direction. And, part of the value is just in the conversation. Other thoughts or reactions? Sarah?
Well, Michael raised it a little bit, but I didn't hear it a lot elsewhere. The amount of food that goes to waste, not just kind of the tops of carrots and things that we're supposed to shove in the garbage disposal, which I learned today. But all of the waste in all of the other aspects of the huge kind of like food distribution and production network, and how we can think about and put energy and mental energy into minimizing that instead of continuing to ramp up agricultural production that's continuing to strain resources more and more. I would just love more mental effort and energy being put into making the most out of what we're producing right now.
Yeah, that sort of goes back to the concept of water footprint, perhaps. We talk a lot about carbon footprint, not as much about water footprint, and that was a little bit of a common thread, I think, from Michael and Tim's remarks also. Chrissy, you were going to say something.
Yes, I was just going to say, I think there's so many engineers in the room. I think that manufacturing could also be, and I mean, not everybody's would be into that space necessarily, but manufacturing, I think, would be something that could go into it. I think that kind of gets away maybe from food in a lot of senses, but at the same time, between implementing policies that are like physical, like we talked about, hydroelectric, mills and all of that kind of stuff. I'm not an engineer, if you can't tell, but I think that would be something that would be good to bring to the table as well.
Yeah, and that gets to some of the triple bottom line considerations and money talks, certainly. So if we can show that it is financially attractive to do some of those things, I think it'll have more legs. Yeah. Jill?
See if I can do this. I think, building on your comment, that an interesting thing to look at would be sort of the inefficiencies that are built into the intersection between policy and engineering technology. For instance, what I'm learning about the agricultural sector is that a lot of the ways that they waste water, or that water gets mixed in with waste and therefore produces more detrimental impacts on the environment, are a reaction to the ways particular policies have either been written or implemented. And if policymakers, producers, and engineers were talking to each other better, that the solutions might be a little more apparent to all of us.
Yeah, excellent point. Yeah, Brian.
So I'm very pragmatic. I want to know how. I want to know how we do this, how we build relationships, how we take some shortcuts. What kind of barriers does policy present towards innovation and technology and the environmental outcomes? 20 years ago, I went through the IGER program, Integrated Graduate Education and Research Training. Interdisciplinary collaboration is fundamental to education. You're dead on to that. I think that is it's a shortcut. It's a way to building those relationships. We need to be more cognizant of recruiting for people with those skills, those soft skills. There's no substitute for time, persistence, patience, and relationships. There's really no substitute for it. Look at Dan and Dave here arguing. You wouldn't have been able to argue 5 years ago and get away with that. And now you're like an old married couple, right? Because you spent so much time together.
It's usually wrong. Like an old married couple.
But you'll work together to make a mutually beneficial outcome for whatever you need. So what kind of shortcuts are there, or paths forward, pragmatic mechanisms that we can develop or get into? I think the IUCRC is one definite great approach to that, where it brings, it's not working anymore, where it brings folks together. I think that's really important. Identifying those areas of need are critical. So I really appreciate this food, energy, water nexus as a concept, as something to rally around. Now let's keep it going and go forth. Again, identifying very specifically what kind of policies there are that preventing technology and environmental advances, and then on the flip side of that, what can we do to spur growth in those areas through policy? And maybe you'd like to explain some of the work that you're doing, Dave. You haven't mentioned that today.
Yeah, well, thank you for the comment, Brian. And my first reaction is hopefully, getting everyone together today is one step towards what you're talking about and forming some new relationships. As far as the work that I've done recently and am doing now, last year's main project for me had to do with chloride transport to waterways. We use a lot of it for winter de-icing purposes here in northern climes. And so we have these chloride exceedances of water quality standards in our streams, rivers, and lakes. It's well known from a scientific perspective, but not much had been done from a legal and policy standpoint to address that. So I, along with some law students, came up with a menu of options that we might use to address that. What I'm working on this year, along with Brian and Matt and others, is how we can better use watershed-based management strategies at various levels of government to collaborate on some really knotty policy problems like agricultural non-point pollution or better ways to implement green infrastructure. And some of those problems do extend across different areas of this nexus. And I think the IUCRC has been a key vehicle for moving some of that forward. Other reactions or comments before we wrap up? Last chance. Well, I do appreciate you sticking with us all day, especially when the weather is, in fact, quite amazing out today. Yeah, I can reveal it now. So in wrapping things up, I certainly don't propose that we have solved any of these grand challenges that face us or even fully explored them. But we have accomplished something, I think. We've seen a robust exchange of views from a variety of disciplines, a variety of perspectives. And speaking, at least for myself, I've learned a lot. So I need to thank a lot of people. I want to thank all of our participants and speakers and panelists from near and far, our organizing committee, especially Brian Weigel, who had, I think it's fair to say, one of the initial visions for this event and led most of our initial discussions about it and our planning efforts. Dean Joseph Kearney of the law school and all of our law school staff who made things run so smoothly today. Our student note takers, our sponsor, the NSF IUCRC, and of course all of you who came here today. Without you, we wouldn't be able to offer programs like this, of course, if there were no interest in them from you. So thank you all, and I hope to see you again at similar events in the future. Safe travels.